Hey everyone, and welcome to this week's News and Community Spotlight. We're excited to be back for GDC 2023. Join us and discover the latest features coming to Epic's ecosystem of tools, attend tech talks and sessions, and play plenty of awesome games at our booths as we celebrate the game development community. To get all the details and sign up for updates, head to unrealengine.com/events/GDC 2023. February's marketplace sale is here, with over 1,500 products now 50% off, so whether you're looking for something small to polish your project or begin the next award-winning game, film, or viral music video, there are savings to be had. Remember to act quickly, the discounts end on February 26th at 11:59 p.m. Eastern. All of the assets you create and distribute on the Unreal Marketplace belong to you. We are updating our Epic Content License Agreement and introducing product tags to give you greater control, protection, and visibility over how your work is used in connection with generative AI programs and how you search for content, inspiration, and more on the UE Marketplace. Learn more about this in our updated agreements. Curtains are almost closing on the submission window to our ongoing Unreal Challenge, but it's not too late. Try something new and join the community in testing your skills in Spellar performance, focusing on all things VFX. Get involved for your chance to win cash, software licenses, swag, and more. For a standing ovation, sparkle over to forums.unrealengine.com for all the event details. Unreal Engine's VR Games Week is in full swing, celebrating PlayStation VR 2, Meta Quest 2, and PC VR games. Journey to the feed to catch all the interviews and behind the scenes of fantastic studios and games, including Horizon Call of the Mountain, The Dark Pictures Switchback VR, Saints and Sinners Chapter 2 Retribution, and more. Developer Smilegate discusses Crossfire Sierra Squad moving into virtual reality and how UE and an Epic Mega Grant helped build an immersive experience on PlayStation VR 2. We recently spoke with Skydance Interactive's chief technologist Peter Ackman on the studio's work on virtual reality games and The Walking Dead Saints and Sinners 2. He talks about how haptic feedback brings the game to life and how UE helped the team overcome challenges for the sequel. Walk to unrealengine.com/feed to learn more. While there, don't blink. Don't open your eyes. Supermassive's new horror game is watching you. In one of our latest developer interviews, we dive into the nightmare rail shooter that is Switchback VR. We discuss everything from deciding to develop a new VR game, the inspirations as well as lessons learned from past creations, and how PlayStation VR 2's hardware is allowing the nightmare to come alive. Inner Space VR explains how it explored a new perspective with Another Fisherman's Tale, its return to the charming puzzle world of Bob the Fisherman. In another of our latest developer interviews available on the feed, Belgian developer Cyborn explains how it created Hubris, a VR action-adventure that has players shooting, jumping, and swimming through a vast alien world. There are over 1,300 community-curated tutorials and courses on the Epic Developer Community Platform. Let us learn together as we highlight 3 fantastic tutorials and their creators. 3D rendering veteran Sergio Durate breaks down their process for quickly creating a 3D photorealistic environment in UE5, starting with creating the sky map and then adding the panoramic backgrounds, terrain textures and displacement, and everything else in between. Glass can be a difficult material to create. In this tutorial, CG artist Nikolay Shemaev shows how to create realistic fluted, frosted, and ribbed glass in Unreal Engine 5 with realistic light refractions, all using flexible materials and parameters. This is one you should definitely see through. Are you looking to add more jump to your step? Learn how to make your jump more animated by applying one of the 12 principles of animations called Squash and Stretch in Blueprints, guided by game developer and education content creator Cobra Code. Moving on over to this week's Community Spotlights. Globally spanning Norian Games brings us a tale as old as dinosaurs, quite literally. Immerse yourself in an ancient world lost in the shuffle of evolution, filled with creatures that impart awe and wonder. Explore a beautifully crafted open world filled with flora and fauna from a bygone age while competing with other prehistoric dino species to become the top dino. Woof. Stampede to their website for more information on how you can follow this fan-triastic game. The NASA Mars XR Challenge asks the larger community to imagine and build out scenarios of tasks required for early human expeditions to Mars in a virtual reality Mars simulation. Help NASA by building XR assets and scenarios for them to use in extravehicular activity research for the surface of Mars and be in for a chance to win a share of $70,000. Warp to herox.com/MarsXR for full challenge details. In the last few years, Marcos Silva and Mick Abela have been creating a live-action short film called Sim, with many digital environments. Marcos's latest spin-off has been somewhat of a personal journey to use the confidence and knowledge gained to practice their photorealistic interior lighting skills while diving into Unreal even deeper. Turn on your light and click over to their art station and let them know what you think of UE5 Living Room. Thank you for watching. Have an epic week.
Hello, everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Tina, and today with me I have two wonderful, incredible guests, one of which you might recognize, who are going to be walking us through a lot of incredible VR tips and tricks today. But without further ado, let's go ahead and introduce our guests. So first off, Victor, for anyone who might not be familiar with you, would you mind telling us a little bit about yourself?
Sure. Hi, I'm Victor Broden. I'm a product specialist on the XR team here at Epic Games. I previously used to host the live stream that we're currently on, and that's why you might recognize me. But today I help making the XR tools in Unreal Engine, some of the best XR tools that we can make.
Very excited to have you back on, and I'm sure everyone in chat is also very excited to see you again. And then next up, Alex, would you like to tell us a little bit about yourself as well?
Sure. Thanks, Tina. Hi, everyone. It's great to be here. My name's Alex Coulomb. I am the CEO of a company called Agile Lens Immersive Design. We're an XR creative studio in New York City, and I've been using Unreal Engine for all sorts of fun reasons for about 7 years now.
Awesome. So excited to get into the content for today. Today's show is, of course, in celebration of VR Week that Epic Games is hosting. So lots of great VR content that's come out this week. If you want to check out any of the other stuff, we'll be dropping English is so hard. Dropping links in chat for you so you can go check those out. But we have so much stuff. I want to get right into it. So Alex, do you want to kick us off? Let's get in there, right?
Sure. Yeah. So it was very nice to be invited to be here. And the goal, my understanding of today, is we want to go over some good tips and tricks and help developers, beginner, intermediate, maybe a few advanced out there, see some new ways that they can start to use Unreal Engine for their virtual reality development needs. Victor, of course, has done a lot of incredible work over the past few years on the VR template. I gave a talk at Unreal Fest back in October, kind of building on some of these ideas as well. Had a lot of great discussions with the community over there. And unless there are any objections, I thought maybe one of the first things we could start off with, in the spirit of just kind of yes-anding a lot of what's in the VR template. I always like to start, and I do this when I teach as well. Should have mentioned I'm an Unreal Engine authorized instructor, and I've been doing training as a partner of Epic Games for about 2 years now. Whenever I teach virtual reality, I usually start with taking the Spectator camera and trying to show people how you can add a little bit of dampening to that to make it a little less nauseating for your viewers. You know, I've been in a lot of experiences, especially in the world of architecture over the past decade or so, where we need to show a lot of people someone inside a VR headset. And so 90% of the audience isn't even watching VR, they're watching someone else do VR. So dampening that Spectator camera can help a lot to make it a smoother ride for everyone who is watching. Should we go ahead and jump into that?
Yeah, absolutely.
Okay, great. So I'm going to go ahead and share my screen. And I basically got a PowerPoint and 2 projects open today. One is the default Unreal Engine VR template that we just get out of the box. Pardon me while I move some zoomy stuff around. And here we are. So this is what everyone sees when they open up the VR template. I'm in the latest 5.1.1 build. And the VR spectator camera right over here, as I'm sure many of our viewers know, is a great way to see what someone is doing in VR. In fact, even
Alex,
if someone...
we're looking at the your notes and YouTube
I'm
right
sorry,
now.
guys. That's embarrassing.
Other
I
monitor.
swear, I've never done that before. You'd think I haven't been teaching for 2 years. Let's try that again. No, it's doing it again. It did it again. You know what? Zoom is actually showing me the wrong screen at the moment. Let's try that one. Okay, here we go, guys.
There we go.
How's that?
Perfect.
Good.
Fantastic. We're off to a great start. So I'm sure many of our viewers recognize the VR template here. And of course, the VR spectator camera, what's also nice about it is it will work even if a VR headset is not connected. I could go ahead and just press play and then press the tab key to come over to here. And even though we can see the VR headset is in the floor, I can still move this around with the standard, WASD keys and that sort of thing. And by default, there is an option for the VR spectator camera down here to go from that fly mode to a first person mode. And in that situation, it will show what the VR player is doing. Now, when someone's in VR, it's a little bit like driving or being in the back seat of someone who's driving a car, and maybe they might be okay as they're swerving around the road and doing all sorts of crazy stuff, but it might not be as comfortable for you as the passenger or the viewer in this case. So there's a really great set of nodes in Unreal Engine in the blueprint side that are used for interpolation, that are really quite nice for exactly this kind of idea of dampening what we're getting out of the whole system here. So up here at Event Tick, this is where we're handling the field of view and then also what's happening in each of these spectator modes. And by default, if we're in that first person mode, it's just going to match exactly what is happening with the VR player, right? And so essentially what we're going to do is change the way that this is functioning. And what we can use is a node called T-interpolate2, which stands for transform interpolate to. And essentially what this node does is it says, okay, where's your thing at? Where does it want to be? What's going on with event tick? Delta time is basically your event tick, and then interpolation speed. How quickly do you want to do it? In most cases in Unreal Engine, if you see something that is set up to be interpolation speed or anything like that, 0 is actually not going to mean 0 speed. It's going to mean do it instantly. And then as soon as you start cranking this up to, 0.001 or whatever, now it's actually going to be moving very, very slowly all the way up to like 100, which would be very fast. So this is kind of the key node that we like to use for, and when I say we, I mean my company, not speaking on behalf of Epic today. We like to use at our company when we're working on projects. These nodes and this whole suite of nodes, there's also like a vector interpolate 2. There's also one that even does springing. I think I can find that. Spring. Nope, I'm just going to type in the word spring and we'll see if that comes up. Vector spring interpolate 2. So this one has also like a spring component. So you could imagine a situation where you might want something a little bit like the third person camera, where something is kind of like moving off of you, but in a slightly different kind of level of interpolation. You can do this with rotation, all sorts of other things. But yeah, let's just start with a very basic version of taking this T-interpolate 2 and getting what's going on with the player camera manager. That'll be what we're getting for current. And then for the target, or sorry, we'll do this the other way around. Current will be exactly what the spectator camera is doing right now. The target will be the player camera manager. So that's what we're going to do instead. So we can get rid of the actor location and rotation. We don't need to play with scale, but it's just a little bit easier in this context to do a full transform. So I'm going to go ahead and just delete that for the moment. I could actually just do this as like a new function or something and not ruin Victor's great work over here, but just for the sake of speed, we'll do it this way. And so coming off of here, we are going to go into actually set actor transform, which is going to be, of course, for the spectator camera as a whole. And then whatever the result of this is going to be the new transform. Again, we won't touch scale and target itself because it is, in fact, what we have here. So for current, we're actually just going to get the actor transform, right? Where are we right now? And then for the target, this is where we're getting the player camera manager. So we can do get actor transform, plug that in. And then for delta time, the easiest way to get a reference to event tick, oops, sorry, is not to type an event tick, is world delta seconds. So we do get world delta seconds. That's the same thing as plugging that float value from event tick into there, right? And so down over in here, now all we need is the interpolation speed. And this is a nice thing to maybe make a public variable. And it will, if I promote it to a variable like that, it's going to say interpolation speed, and we'll compile. And 100 is going to be very fast. So I'll start off with 2. We'll just see what that does. And if I've done everything correctly, what's going to happen now is when we're in that first person view mode, we'll see a slightly different level of speed. And sorry there for Microsoft Teams, I'll get rid of that in a moment. And what's going to happen when I come out of here is I can go down and I can see that if I'm in first person mode, I'm also now going to have not the field of view interpolation speed, which is similar, but a new one, unless I forgot to make it a public variable, which is possible. There we go, make it a public variable, hit the eyeball there. And now we'll see that it is right there under interpolation speed. So let me make sure my VR headset is still connected, because all of us VR developers know that sometimes a headset decides that it no longer wants to be doing its AirLink sort of thing. In this case, I'm using the MetaQuest Pro. Looks like it's still connected, although the floor has changed height a little bit. Should be okay. I'm going to hit VR preview. And we'll notice, of course, that by default, we get, every little shake, every little movement of what's happening with my head, and that's translating into what's happening here. But now if I go ahead and I press the tab key, you notice we actually also get that interpolation of where it was and where it is now. And now I can still shake my head a lot, but it's a much smoother view. So that's very comfortable. So now you basically have 2 comfortable views of what someone might want to have for VR. One is looking at it from here, and then one, of course, is looking at it from the player's view. Now, what if you want to switch these at runtime? I don't want to go into all the details of expounding on this node too much, so let me go ahead and open up kind of my finished project here, and I'll just go over briefly a couple nodes that you can do if you actually want to actively switch between the 2. And I should be able to just pop right into here and see that active at the moment. We'll fix that in a second. Just hit play in editor. Great. So over here now, if I press the tab key, we'll see, there we go. I've also got some hand tracking here, a little preview of something else we'll talk about. And we've got that third person view, and I've actually got it mapped right now. So if I press the M key on my keyboard, that's what's actually going to switch over to that first person view. So I can go back and forth, right? And so now we can go ahead and take a look at this slightly expanded upon version of the blueprint. And so you see there's a little bit more going on down here, right? So what the M key is doing is it's actually swapping between that first person spectator mode and the fly mode. And here's the thing, when you go into that first person mode, even the dampened one, by default, that's going to be where that spectator cam lives now. So one additional thing I've done here is try to have an additional variable, which is that last free transform. Right before you kind of told the spectator cam, hey, go over and try to be exactly where the HMD is, let's get that so that when you toggle back into that fly mode, you still have access to that. And that's what's happening there. So we're getting that, we're storing it. I just got a little debug print string to remind me that we're about to switch over to matching the spectator cam. And then when we're switching back over to being in fly mode, then we're getting that last free transform and resetting that spectator cam location. And then I've just got a couple other little cleanup things going on here. I did notice sometimes that when you're dampening the camera, you start to see the headset a little bit, the HMD. If you move forward really quickly, it might be trailing a little bit. So I'm also hiding the spectator camera and making the camera only visible in the scene capture as we start to set that up. And then down here is essentially the same logic that we were just looking at before, except now I've just got it over in its own custom event. So I'm actually not touching the original event that is over here, right? So this is the original one over here, and then I just skip right over to calling that event to match it. And then you just have a little bit of a, dampened spectator camera, more helpful. And I hope that as we show more VR things over the course of this live session, I'll remember to use the dampened view, and that should make for a more comfortable viewing experience. Victor, anything to add?
Yeah, I was just going to say it's really useful to use it for purposes such as recording, trailers for your game without having to tell the person who's operating the HMD to like, hey, please move slower. No, even slower than you do normally. And then instead you can sort of let them do a normal play session, but still have something that comes through on a flat monitor and that you can follow along and actually view yourself, because it looks much faster on a flat monitor when you're sort of just playing a VR game than it does when you're actually in the HMD and you have such a wide field of view.
Excellent. Yeah, and as I'm pulling up another example of this, so I like to try to yes and when I'm teaching, here's a cool technique, here's other ways you can use it. So I'm going to pull up in a moment another example of using this dampening, and it's with the menu system. So the way that Victor has designed the menus in the VR template is they pop up above your hands, and you have this nice little set of, resetting your location and position, of quitting the game, of restarting the game. And all I do in this scenario is take essentially the same setup, but just move that menu to the center. So instead of having it above your hand, it's more of kind of your standard dampened menu that is free floating in space. So let me see if I can pull that up for a moment. Victor, do you want to talk a little bit about the menu while I'm doing that? Because I know a lot of people don't even know there is a VR menu.
Sure. By default in the VR template, since 4.27, there's a hand menu that comes pre-configured. It's easy to add new menu entries, whether you want to customize that for in-game menu. But what I've seen a lot of folks use it for is for quick and easy prototype development, giving the ability to give QA the option to sort of spawn things or do cheat codes or whatever. But you can also definitely use it as an in-game menu. It works automatically if you put your hand up and you're aiming at it. It works like a laser pointer. If you take the hand off, you can just use the thumbstick to control it, which was very important for development because you don't want to take up two controllers every time you want to use the menu. It comes with a couple nice little Niagara particle effects that you can use for a lot of other things. So if you just want to learn how to draw a line between one point and another and do that in a very efficient way that works on standalone VR as well as PC, you can just go ahead and check out the Niagara particle emitters that are part of the menu system. So the logic is a little interesting in there, sort of the automatic switching. I would leave the automatic switching logic as it is. It could be a little tricky to customize, but anything else in there, sort of adding new menu entries and customizing the look of it, and the menu will just work. And I should note that we are aware that when we shipped 5.1, we had an issue where buttons would only work once. We fixed that in the .1 hotfix. So if you haven't updated yet, go ahead and do that. And this was for all widget interaction component interactions that it was broken, but we fixed that now, so it should just work.
Excellent. Sure. And yeah, keep talking, Victor, while I just pull up something else here as well.
Sure.
I know we're going to be bouncing back and forth between getting things ready in VR and just having a chat.
No, you're good. Last time when I did this, I always bring someone else with me that can actually use the HMD.
Yeah. Oh, that's a nice idea. I need a Vanna White here.
Maybe next time we'll fly you down to HQ and we can I was actually I walked over to the old studio and I was thinking, can I do a live stream from the studio?
Yeah.
Just sitting there with my laptop would have been funny. But not at this time. I was going to say, for those of you who don't know, Alex is using the MetaQuest Pro. That's the HMD. He's using the Oculus Runtime. And what's important to know that if you are doing VR development and you're switching HMDs, primarily HMDs that use different runtimes like Oculus, Steam VR, it's important to know that when you're using OpenXR, you have to switch the active OpenXR runtime, which can be done using an environment variable, but that's unnecessary because we have tools that can do that much easier for you. And so maybe this is a good time to plug the OpenXR Explorer tool from GitHub.
Ooh, yeah.
I will go ahead and paste that link in Twitch chat, and then maybe Sky can go ahead and get that into YouTube as well. This tool is useful for more than just switching the active OpenXR runtime. I use it to verify which OpenXR vendor extensions that different runtimes support. Not all of them are required to support all of the same extensions. And when you switch runtime in OpenXR Explorer, you can actually see what extensions and layers are currently supported by the runtime. And that can be really useful to know whether or not the current runtime you're using or which runtimes support extensions that you may or may not use for development of your game. Hand tracking is an extension. Another one is the eye gaze vector, for example. These are some of the ones that we natively support with Unreal Engine. And since I am on the spiel about OpenXR, it's also worth mentioning that any vendor-specific OpenXR extensions, and what I'm talking about this, it's worth noting that a device vendor might have the hardware feature or a software feature that is not very generic, or that device vendor might be the only one that has implemented support for that. For them to support that through OpenXR, they develop an OpenXR vendor extension, and support for that vendor extension in Unreal Engine typically comes from the vendor developer themselves. So if you have a question such as, why don't Unreal Engine support device feature X? It's worth finding out whether or not that is an OpenXR extension, a generic one that all runtimes implement, or if it might actually be a vendor extension, which not all runtimes are required to implement. And OpenXR Explorer can be a really useful tool to find out what these extensions are, and get a little bit more of a almost like real time, but you can just sort of look into what the runtime currently has enabled. And I'm going to get back to a little bit about OpenXR vendor extensions later in the live streams as well.
Yeah, excellent. Should I show menus real quick?
Yeah.
Great, let's do it. And I'm going to try really hard to show the correct screen. This one. Screen 1 and screen 2 are opposite from what I would have expected.
There we go.
There we go. We're showing the right thing. So let's see. This is the one that's modified. Let's start by showing how the menu normally behaves. And basically, every event tick, what's happening is we're getting this motion controller aim reference, which is on the coming off of the motion controllers. It's used also for the pistol, right, Victor?
Sorry, I was reading chat.
Sorry, that might not be true, actually. So the motion controller aim reference, I was wondering if that has anything to do with positioning the pistol, or if that's entirely about like the little raycast that comes out for menu options.
So the aim reference, this is for the menu. That's specifically. Yeah. So, okay, maybe let's take it back sure. Step. Yeah. There are different poses that the OpenXR runtime returns for where your motion controller is.
Right.
If you open up the motion controller component and go down to motion sources, it's always good to have a direct relevance to. When understanding OpenXR, it's really useful to use sort of Unreal Engine as an example and see how we've implemented all of these, all of the OpenXR features. And so Alex is looking at the motion controller component here. Under motion source, you can select which pose should this motion controller component actually track. By default, we have left and right, and the reason why those are still in here is for backwards compatibility with projects that was previously using the native VR SDK, such as Oculus and SteamVR, also OpenVR. It's still SteamVR, but they're now using an OpenXR version of the runtime, and that's why you'll see left and right in there. Left and right actually refers to the grip pose, which is going to be a pose that the runtime decides where it is, but in general, it's going to fall in line with wherever the grip button is on all of your controllers. And just to give another example, we got the Valve Index controller. It will be somewhere around, on both poses, somewhere around here. It can be useful to visualize these when you start developing, if you know that you're doing cross-device development with OpenXR, to sort of get an idea of where they are. So that's the grip poses right here. We can also switch the motion source to left aim and right aim. Those poses are going to be sort of up here on most controllers, and they refer to a good placement where you would like to do a line trace from the controller. And you can select those. In the VR template, you can see that we actually have 4 motion controller components. You don't need to use 4 motion controller components, but it's really easy to have a component to sort of just attach things to and reference, rather than using the get motion controller data function and returning these values directly and then creating a scene component and then attaching things to that. And so you can see that we have motion controller right and left aim, and we also have the default ones. And so in regards to the logic that Alex was referring to, I am simply just, I think on begin play here, I'm getting a reference to the motion controller component that is listening for the motion controller aim pose returned from OpenXR, because that's actually the one that we want to use for our trace when we're looking for where the menu is and where to put the cursor on it.
Yeah, so here's the left aim and right aim that it's searching for. Victor, I've also been hearing a lot of people talk lately about when to use branch and when to use select. I'm curious if you have any quick thoughts on that.
Context sensitive.
Yeah.
I would say, yeah, it really depends. I can't answer whether one is cheaper than the other. I think if you're going that granular into performance, you have other performance problems that you should probably tackle first. However, having a series of like 10 or 20 branch like if statements in a row, you might start to reconsider how you're doing that logic. Not so much for performance sake necessarily, but just that seems very difficult to manage. Maybe break that up into an enumerator or some form of switch. Remember, code is for humans, or at least, scripting definitely is for humans to read. So making it easier for us is typically more important, at least when it comes to gameplay logic, than thinking whether or not this if statement is more expensive than this select, etc.
Right, that makes sense. Okay, so just to demonstrate the way that this is working right now, we're going to spawn a menu right above our hand. And actually, Victor, to be clear, are we spawning the menu every time, or do we just collapse it?
It's just getting scaled up and down.
Yeah. Oh, here we go. Yeah. And we have a little timeline animation for scaling up and down. Okay. For anyone who has no idea what we're talking about, we should show what the menu actually looks like. So this is the default behavior. If I come in here, and I can press my Y or B button to trigger this, and it'll take a second to compile my shaders. And you see that I have two different ways to access this. I can use my thumbstick to actually rotate around and select an option that way with the trigger, or I can use my other hand. And this is where that aim component that Victor was just talking about comes in. And I could select an option here, like reset my orientation, right? I come over here, reset, and it just keeps snapping back to the front. Really handy. That only recently started to work with OpenXR, and we're glad it does. And you can see I can do the same thing with my left or right hand. Here on the Oculus controller, I can also press the little settings button in the bottom left. So I basically have three options to bring up the settings menu. And it's great. So the slightly modified, just alternative way that I've been teaching how to use this involves basically going into that same component and then just doing a little bit of dampening and resizing of where the menu is. So right here, when we say move the widget to a comfortable location, I just added in front of camera. And so here's our vector interpolate to, and we're basically saying, okay, where is it right now? Let's go ahead and figure out where the player camera manager is. And then we're doing a little bit of vector math just to say how far away from the camera do we want it to be. In this case, I have 75 centimeters. And then we're still just doing it over delta time with an interpolation speed and just positioning it like that. And then I also just have a version of the spring interpolate to here as well. That feels, in my experience, a little bit too springy for something that's like a menu, but it is kind of cool to see how that functions. I also have a do once up here. I'm sure I could also do this at begin play or somewhere else, but I did find it's a little bit weird every time you spawn the menu to have it like, fly up from wherever it was. So whenever we are activating the menu, I just have a very quick moment here where we just actually set it like directly to the place it wants to be, essentially skipping the lerping part, the interpolation, and then it moves pretty smoothly. So let's see what that one looks like. So I can go ahead and press play. And I'll go ahead and press my menu button. And now you see it's not connected to my hands. It's in front of me. And as I turn my head, it just kind of follows my head. It's pretty comfortable. I always find it a little bit unsettling too when something is like perfectly in the center of your screen all the time. And actually we can simulate that pretty quickly as well. Oh, and sorry, I realized I'm not showing the spectator view. But if I were to go to the menu there and I were to change that interpolation speed to 0, right? This would essentially be the same as just doing this on every event tick, right? And I'll press play and we'll get the spectator cam up. And actually, you can also see the menu in the spectator cam. Oh no, our first crash. It happens. Classic. Send and restart. Should only take a second. Yeah, I kind of like that you can see the menu in the spectator. You can see the menu in other views as well. We've done a few little tests with multiplayer as well based on this. And it's also kind of fun to see like what menus people are pulling up at any given moment.
I would recommend, if you're considering doing a large player scale multiplayer game, that you actually spawn a proxy of the menu. So what I mean by that is a very cheap representation of something that looks like a menu, because spawning many of these 3D widgets in a scene will very quickly tank your performance. And so if you do have a multiplayer game with, I would say, any more than 4 players, I'd recommend that when you do that spawn and you replicate that call to all the non-owning clients, that you actually spawn some form of proxy, something that's very simple, an actor with just a plane that maybe says menu on it, or however you want to design that. but that will be much cheaper to do rather than yeah, you don't have control as a developer over if every single player opens the menu at the same time. And drawing that, particularly on a standalone VR unit, could be very expensive.
Yeah, absolutely. So I also just want to mention, as long as we're talking about the menu, that it's very easy to add your own buttons to this. Literally, you can just bring down the button component if you open up the widget menu and then name them whatever you want. And then all you're going to have to do is get a reference to exactly what's happening in there. This is an example I use when teaching for if you want to create some waypoints. So you want to set up any locations around your level and want to allow people to kind of warp over to them. In this case, I'm just using target point and giving a tag to each one for how we get over there. But basically, you end up with this, with each button, just an on pressed. And then in this case, I'm doing a little fade toggle for it. But you can also just do something like console commands. So let's do this really quick because it should only take a second. So we're back over in our main one here. I'll pull up the menu, not the menu blueprint this time, but this time the widget menu. And all I need to do here is drag down a button into my vertical, not into there, button into my, I guess I can put it in the vertical box. The other thing you could just do here is actually just duplicate two of these, right? So they come as a pair. How did I delete it? Oh, it doesn't have duplicate as an option. Hold on one second, duplicate. There we go. It comes with the text together. And then you can just reposition these wherever you want. So I could have something at the top. And let's say I want to use a nice console command like stat unit, for example. So I could call this one, I could go into the text and call this stats. And then what I do is I just go back up to that button, which I probably also want to rename from exit button to stats button. And then I just scroll down here and I can just say, what do we want to do when we click that button? I hit a plus and we get that little on clicked. And then I could literally just say, you know, execute console command and do stat unit, for example, or anything else. I could add a whole string of these. And you can see everything else going on here is pretty simple as well, right? So the on click for reset orientation and position, that's a single node now. For restarting, it's just grabbing the name of the level and reopening that. And for quitting, it's literally just calling that quit command. So real simple. And we'll just see what it looks like when we have the menu pulled up. And I bet Victor knows what I'm going to want to say after this, which is that when we do pull up something like stats, we'll see where they appear on the screen, right? So if I go ahead and have this guy and I click stats, so this is a little bit hard for me to see in VR. It might look okay on the screen, even though it's a little bit small. And so, you know, I can kind of tell how many primitives I have and all that, but really someone who's actually watching the spectator view is going to have a better idea of what's happening than me. So Victor, I know we've heard a few different ways about how to go about this, but how would you recommend people position any kind of text in a little bit more of a central way for someone who wants to see it in VR?
There's a few ways to do it. When it comes to information that you can sort of get at runtime and game logic, I like to actually put it on the menu itself. So essentially making your own little debug,
cool.
little console command. I would like to see us, I'm not entirely sure if it's possible to just scale the size of that overlay in code. It's possible. I don't know if that's exposed to the editor. That might be the case. It also depends a little bit about it depends a little bit on the resolution of the actual HMD that you're using. In some headsets, it's easier to read than others.
Yeah.
Something that I think there's quite a lot of quality of life improvements that I would like to see us do, this being one of them, being able to essentially have an easier time to read all of these statistics. Yeah, I typically look at the screen, like the regular screen, when I'm doing any of this, because like stat FPS and stat unit, that might be fine. But as soon as you're trying to do something else, like stat memory, stat RHI, now reading that in the HMD is not really the most comfortable way to sort of consume that data. And it should always only be used when you're doing that. All of that should only really be used as like a quick reference, not necessarily like, oh, I'm doing you know, performance benchmark of my game. Don't just look at a value that is changing every frame like that and try to make an assessment whether your game is hitching or not. Try to use our debugging and profiling tools such as Unreal Insights or dump hitches. Yeah, dump hitches would print out a log of if you have any hitches and where they were, etc. Start on pitches. Yeah. See, I saw another point about someone asking this on Twitter just the other day. It's like, hey, real developers, we use Google all the time, and that's because some of these things are really difficult to remember, like all the thousands of console variables that we have and the commands to use them. But in the sake of like for frame rate, for example, which is typically something that I want to have on at all times when I'm developing, because you never know what little thing you might have changed that causes performance issues. So, and it can be difficult to notice them. Today, when we're running such high frame rates on our HMDs, it can be difficult to even notice, particularly if you're a VR developer and you're sort of used to poor frame rates sometimes, depending on what you're doing. And so being able to just take delta time, 1 divided by delta time, and printing that out into like a text render on your menu, it will give you the frame rate. And always having that like attached to your hand, or just as a HUD, a heads-up display solution, sort of similar to what Alex did with the menu. Those are good recommendations to have a good idea of what your frame rate is throughout development, and not just like every week when you're running a test, see have we regressed in the last week or not. And then rather than that, you can immediately see if you have any problems.
Yeah, absolutely. And that might, the only other thing I was going to mention as well is I saw someone, I'll find your name so I call you out properly, who mentioned that for VR, they also just like to add like a bunch of spaces whenever something is going to be printed, if they're using, for example, the print string command, and you can just kind of like force some things to be more centered. Victor, you'd mentioned also just turning that into part of like your macro library as well for like a VR print string. I think that's a nice little tip.
Yeah, I typically make either a function or a macro library, and that I call like VR print string.
Yeah.
And in that function, I will add spaces and enters to the I will add that prior to the actual string that you want to print, just to sort of get it in a nice, comfortable placement, because typically it's only up in the top left. Nice little hack. But to make that even easier, and potentially something that you can sort of go and say if you didn't set the proper delay on your print string that you wanted, and you still want to see what happened without opening up the console, I typically also add a function in there where I simply just call that to, and I add it to like an array of strings that I am then actually printing to like a section of the hand menu. So you can have a button in the hand menu that tells me, hey, show me all of my print strings, and then you can actually open that up. There is also in the VR expansion plugin actually has the console in VR, which is really, really useful. There's a component you can add to anything that you can grab, and then you can also actually have the console in VR, which is really useful.
Yeah, the VR expansion plugin is wonderful. And for anyone who doesn't know about it, just 90% of the things that you would like to be able to just use out of the box in VR, there's some implementation of that. There's multiplayer, and there's like dealing with collision of objects, and head fades, and dash teleports. Yeah, everything. Physics.
Replicated physics.
Yeah.
Yeah, we'll probably go into the VR expansion plugin a little bit later. I almost didn't want to mention it there because I know that it's easy to get stuck on that. But we'll get back to talking about it a little bit later, because we have some questions that plugin can solve.
Excellent. As long as we're talking a little bit too about, I just saw my headset go like it's dead or it's gone. I have to get it back in a moment. As long as we're talking about debugging and iterating and that kind of development pipeline, maybe this is a good part for our friend Dan to queue up a video of a tool from NVIDIA called VCR, which stands for Virtual Reality Capture and Replay. This is something I've started to use a lot in our development pipeline over the past year or so, because what it essentially allows you to do is record any kind of OpenXR data that's coming in through SteamVR, what your headset's doing, what your controllers are doing, what your inputs are doing, and to then actually play that back as a perfect replica over and over and over again, which is excellent for if you're iterating on something. So the little video we have today is something I was playing with when I was trying to convert the VR pawn to a VR character, and wanted to make sure that when we were doing snap turns, that the snap turns were going to work correctly. So rather than constantly putting on the headset, trying to move around, try to do a snap turn, take it off, try to figure out what went wrong, I was able to just keep playing back that same data over and over again while I modified the blueprint code. And that was a much faster iteration pipeline than what I was used to.
And this is a good time for me to mention that we've actually been developing a very similar tool internally. If you keep a close eye on GitHub, you might have seen a commit related to it. We haven't released the plugin yet, but we're working on a tool called XR Scribe, which will essentially be able to do the same thing, and we'll eventually be shipping that natively with Unreal Engine. Should probably do another live stream, or at least a video about how to use it whenever we decide to chip it.
I'm
Excellent.
always down for that. So
Cool. Do we have access to the video there about VCR, just to give a little visual for what we're talking about?
yes,
It is playing.
It's
Oh, it is playing. Okay, great. I didn't see it. Excellent. Yeah, I got to watch the stream more.
I think.
Yeah, and in the final iteration, I was able to then like get the correct pivot point, so it's offsetting properly. And Victor, do you want to talk a little bit as well about, you know, using a pawn versus using a character, especially in the context of VR?
Sure. Maybe we should open up the blueprints, because it's a little bit easier to understand the relationship between the origin
Excellent.
of the actor origin.
Yeah. Okay.
So
here's our standard pawn, right?
yeah. Let's open up the character. We'll
like
start there and we'll work our way.
Like an actual, like just create a character from scratch? Or...
Sure. Yeah. That's perfectly fine.
Great.
So in Unreal Engine, we have the concept of not the concept, but we have a character, which is a pawn that comes very coupled with a component known as character movement component. This is what you, unless you have a bunch of very talented networking engineers on your team, this is probably how you're going to go about developing a playable player-controlled character for multiplayer, whether that's flat games or VR or AR. The character movement component is very specific to this class, and you can see that the root component of this pawn is a capsule component. Now, when we're doing VR, where the player is in the real world is always going to be relative to where the center of their tracked play space is, which is typically the center of, where you painted your chaperone or your guardian, or your play area bounds is what we refer to them generically in OpenXR as. And what that means is that this collision cylinder, which is actually doing all the calculations, like, can the player stand here? Is there a ledge that they can walk over? That cylinder is actually not coupled to where the player's camera is in the game world, because you can physically walk around in your play space. You can't know that the player is always standing dead center in the center of the play area bounds, and never moving there. And so there are a couple of things you can use the character, so a character, which is inherited from a pawn. You can use it to develop VR games, but when it comes to multiplayer, the hacks that you would do in blueprints to actually make this collision cylinder follow the virtual camera, those are not recommended for a multiplayer game. So it's worth mentioning that, like, while you can use a character for a lot of like the walking locomotion methods and other various useful features that the character movement component comes with, I would not recommend that route if you're actually trying to do a multiplayer game. So I did mention a little bit about the origin there. Yeah, let's go to the VR pawn, and I think you're in 5.1.1. I'm not sure if I did this update.
I'm in 5.1.1.
This update just yet. So I actually just renamed the default scene root to be called the VR origin, because it becomes a little bit easier to understand this concept. So there's always going to be a root to the actor. In this case, it's the default scene root. Like I said, I renamed it to VR origin just to make this a little bit easier to understand. But the relative location of the camera relative to the root of the pawn is typically going to be the relative position of the player to the center of their play area bounds. And this is an important concept to understand, as it really changes, because when you're moving the player in the game world, you're actually moving the pawn itself. And if we go to the teleport function, you can see that we have, so that would be try teleport.
Try teleport, yeah.
You can see that we are actually doing a little bit of math here to figure out where are we supposed to put the pawn, so that the pawn as the actor, which means the root of the pawn, where are we going to put the root of the pawn so that where the player is pointing to, I want to teleport here, is actually where their head ends up in the game world, where the camera ends up. Because otherwise, if we didn't have this little logic here, you would move the root of the pawn, which is not where the player is, relative to that in the game world. We would actually move that to the teleport location, which could, if you have a large play space, that could put the player somewhere in a wall, or you have no idea essentially where that player is going to be as the developer. I think I do talk quite a bit about this in the OpenXR live stream that we did for 4.27.
Yeah.
So it's a little bit outdated at this point because it's using the old editor UI. But there are a lot of concepts in that live stream. Most of them are the same. The VR template is almost exactly the same. But if you are new to Unreal Engine and you started with UE5, you are going to take a look at, and you want to watch that live stream, you are going to see an old version of the editor. And so some things will have moved around, but all the logic and the concepts are still going to be the same.
Excellent. Yeah, and I'll just open up as an example, again, not like an official version or way to do this, but just in my own experiments of turning this into a character. Basically, the first step, by the way, for anyone who does want to play with this in you know, understanding the risks of what could go wrong, all you have to do to start actually is just convert the class. So you can just go up here, and instead of pawn for class settings, you can just change that parent class to a character, and you'll actually see how this evolves pretty quickly and changes. So it starts to add in that capsule component, and a bunch of this stuff needs to be organized and moved around afterwards. But as Victor said, you know, there are some benefits to using the character side, especially if you want to easily toggle between like a walk mode and a fly mode, a swim mode, all those things that come with the character class. And so we look at the one that I've put together. I just want to call out a couple interesting things in here. First of all, the way that it's organized. So we've got that VR root, kind of like what Victor was just describing. We have the camera and all the motion controllers positioned as 000 under that root, but the root does have a little bit of jankiness to try to compensate for the way that capsule component sort of messes with how the VR pawn gets placed. And then everything else is pretty much the same here. The movement does just become a little bit different, especially for something like our snap turn. And so when we do have a snap turn, I'm not going to go into all the details of this, but there's basically a whole bunch of vector math going on that is figuring out, you know, where you are in relation to your play space, because you might be moving around, and then dealing with, in some cases, actually moving your play space a little bit beyond how you'd actually want to, just for the sake of making sure that if you are doing a snap turn and you're doing that rotation, that everything starts to get back to where it needs to be. And this was a little bit more of an arduous process than I was expecting. It's not recommended, I'd say, officially in any way. And there's a lot of other plugins that do this well. But this is just to show like a little bit of what a development pipeline could look like. Cool. All right. And as long as we're talking, Victor, about some of the differences between the 4.27 version of the template and the newer one, I feel like we have to mention a little bit about everything going on down here.
Sure. Yeah. In 5.1, we added hand models to the VR template and the VR pawn. And we also updated the templates to use enhanced input. This time, it's worth mentioning that for right now, we do support the legacy input method for OpenXR. But as we get closer and closer to implementing full support for the action system in Unreal Engine, so the OpenXR action system in Unreal Engine, enhanced input is the recommended path for input when you're doing XR development with Unreal Engine. So with that said and out of the way, we are using enhanced input to get the touch events from controllers. And we use those events to drive an animation blueprint that is then blending between just static animated hand poses. So it's a very simple way that we're doing hands here. We are not using the hand tracking data that you can get from OpenXR in the template at this time, and that is primarily because currently with OpenXR, there's not a way for the different runtimes to sort of take this touch data and pipe that through as, you know, hand tracking data. There's no requirement, the runtimes are not required to do that. And so if you do want to be able to support both hand tracking with the same model with the hands in the template, and sort of simple controller, my thumb is on the thumbstick, my finger is on and off the trigger, you would have to sort of blend between these two separate modes. You can do that by checking whether you're receiving hand tracking data, and if so, you know, switch to using the hand tracking data and drive the animation blueprint using that. Instead, yeah, I think Alex actually has a function for mapping all of the data.
Yeah, so here's what Victor was just talking about of toggling between controllers and hands as well. Oh, that's the manual one, but we can also detect it. Yeah.
Yeah, whether or not we have that data. There's a few ways that you can detect whether you have the hand tracking data. So that, yeah, motion controller data. This is a useful function to get, because basically from this function, if you split that struct, the motion controller data struct, here we can see a bunch of the data that some of it we're using to drive the motion controller component, but it can also be really useful to just reference this data directly, and you do that through the get motion controller data function, making sure that you're operating on the proper controller hand that's being returned here. So whether it's left, right, or aim pose, or grip pose. Do you have a specific question there? I think I just went off of the get motion controller data function.
Yeah, and I thought I would just demonstrate just this particular implementation. So we saw for a moment what it looked like when I had it active, and then I've just got a couple quick little slides, although I probably need to get this guy up and going again. But yeah, I can kind of show just the basics of how this is set up. There's some good little tutorials on it. But over here, if I do my slideshow, I've got literally like 200 slides over here about different VR stuff. So I need a good like Control F. Here we go, hand tracking. And
this guy is on top of all the links as always. I was trying to gather them here and just took a peek at the Twitch chat, and they're all right there.
Yeah, she's the best.
Excellent. Thank you, Sky. Yeah, so just real quick rundown of this. So basically, we have a blueprint for a rigged hand, and then you need some kind of hand skeletal mesh. A lot of the finger data and all that tends to be the same, but there's also some that you can get from various like OpenXR libraries that work well here. And then really all you need is that posable mesh hand for this particular implementation, which is what we'll use to actually adjust the fingers going on. And so then what we're doing here is we're getting that motion controller data. This is basically exactly what we were just looking at, where Victor just had me split this directly. When you do a break, you're just kind of like pulling it off to be its own thing. And then here's all the stuff we're pulling out for the hand key positions, the rotations. And then we're just deciding that if we are finding the hand, to then spend the computational cycles to update those joints on every tick. And so then essentially this is what you have for the variables. You're figuring out if it's the left or the right hand, the names of those joints, the bones, so to speak. And then, yes, those vector and quaternion positions. Here's what these all are named in this case. And
it's worth noting that the hand model and the skeleton that is part of the VR template, the names of those joints directly matches the OpenXR specification for the EXT, for the hand tracking extension. And so they directly match.
Yeah, and it's also worth mentioning too that in order for this to work, you do actually want to go into plugins and find that OpenXR hand tracking extension right there.
Should note that they were all supposed to be enabled by default in 5.2, but feature development locked down a little sooner than expected. And so in 5.3, all of the native OpenXR extensions will be enabled in the template by default.
Excellent. Yeah, and I noticed in just the GitHub poll of 5.2, Victor, I saw one more for the OpenXR like Vive tracker support. So is that just going to be like another easy way to make sure Vive trackers are working well?
That's correct. And it's worth mentioning that that is not an official extension, which means that it's a vendor extension.
Gotcha.
So currently that extension only works with SteamVR as the runtime, potentially Monado as well. If you're not familiar with Monado, it's an open source OpenXR runtime, which is worth noting.
Yeah. How does Monado compare to something like ALVR? I've heard people talk about the differences between those before.
Is ALVR an OpenXR runtime? I thought that was just a means to sort of stream.
That's right. Yes, I think ALVR is a little bit more like a virtual desktop or like an AirLink kind of system for.
Yeah, Monado is an actual OpenXR runtime, so it is the bridge between the hardware and then the application. So that is how the OpenXR runtime acts as an intermediate bridge between understanding what the hardware is telling, the data that the hardware is giving to the computer, and what the computer is then giving giving to the application so that we can act upon that data and build applications and experiences.
Right. That makes sense.
If you are interested in sort of getting more in depth with OpenXR, looking at Monado is a great way to see how you would go about building an OpenXR runtime.
Excellent. Just making sure I've got this guy pulled up just to show this. So you can see here, I've got a whole bunch of different pawns, and essentially all I'm doing is I swap between my different pawns. I'm just dragging them into my scene and saying, you know, auto possess player 0. I could, of course, be changing things like in the game mode, but this for me is just the easiest way to do some quick swaps. So when I press play here, I'll go over to my spectator cam and we can see that I have hands. And what I particularly like about this extension is I have tested this running with the Meta system, both the Quest Pro and the Quest 2. I've tested it with a Varjo XR3, as well as with the Vive Focus 3 and XR Elite, which I also have over here. And it works great with all of them, which is kind of nice, just to have this one kind of system that can do a lot of different hand tracking, and it looks pretty good. We'll go over to the first person view mode here to see a little bit closer. So you can see my hands probably in the camera, and you do still end up with some of that occlusion, you know, where if you have like one hand over the other, it starts to freak out a little bit. But for the most part, as long as you have good visibility, it's going to be fairly accurate. And you'll notice I even get like some Oculus gesture support, which is quite nice here too. Yeah.
Yeah, we don't see that overlay since that's done.
I'm sorry. Yeah, right. Okay.
That's done in the
Like,
compositor and
yeah,
not the application.
I can see the Oculus.
Yes. And it's worth noting there as a general tip, if you do want to capture and or see exactly what's being viewed in the headset, there are different ways to do that depending on which runtime you're using. SteamVR has an option to essentially show you exactly what's being displayed in both eyes even. And I think that's possible to do with the Oculus debug utilities as well. And then you would be able to see what Alex was referring to, which is the Oculus sort of all the menu interactions and stuff in Oculus. So when you hit the start button on the Oculus, if you want to see that on your regular monitor for whatever reason, you actually have to display the debug utility view. I'm not sure what it's called in the Oculus runtime, but it is possible to view all of that in both Oculus and SteamVR. But those are going to be specific to the runtime and is completely outside of the realm of Unreal Engine.
Right. That makes sense. Yeah, and then if someone wants to just like test like a left eye, right eye thing, like we know that sometimes there are certain features in Unreal Engine where you might only see them in the left eye and not the right eye. You can test that even without having a VR headset handy. You can launch with, I think the command line is emulate stereo, and it will actually give you a left eye and right eye view, right, Victor?
Yeah, that is correct. If you add -emulate stereo, one word, as a argument to the target line, so essentially you make a shortcut of either your project file or the Unreal Editor file, and you add -emulate stereo to the target line there, you can actually hit regular PI, so plain editor, or I think it even works in plain viewport, and we will actually emulate two eyes completely without distortion. And the runtime, there's actually no OpenXR runtime active at that point, but it's how we do a lot of the debugging for rendering issues between left and right eye, for example. Typically, the rendering engineer doesn't even need a headset to be able to debug that. They can just launch the project with emulate stereo, and then we can see what is going on in the two separate views. So you wouldn't really play the game like that. It's primarily to debug rendering issues and look at different things without actually having to use a headset.
Right.
You know, or you can get a robot arm and put a headset on it, and yeah.
That sounds like a fun option, personally. So.
Yeah, I've been trying to get one over XRQA to develop a little or build a stand so I can put the HMD on it.
That'd be too good.
That sounds pretty good. Just to demonstrate exactly what we're
nice.
talking about. So yeah, so I just created, you can do a shortcut. I like to use batch files because they aren't tied to any particular directory. This is just the Meerkat demo from Weta, and I could just grab this entire folder and move it around somewhere else. You can see I also use batch files for things like launching pixel streaming, but in this case, it's literally just the exe file for this -emulate stereo. And then if I open that batch file, it's just going to pop up and we will see a left and right eye view. And we can see that the right eye is doing some different things. So that's really handy from a debug perspective.
Yeah, I think this project is using unsupported stereo features by default.
Ah, I see.
I'm not entirely sure. I never launched a Meerkat in stereo, actually. Cool. I did see a question come in, and we were briefly touching on this in regards to why OpenXR? Why should I use OpenXR rather than sort of the proprietary SDKs for the different devices and runtimes? There are a lot of reasons. But the one that I would sort of double down as the most value for you as a developer is the fact that you can develop cross-device applications without having to have a bunch of if statements. Is this SteamVR? Is this Oculus? Etc. And it makes it so that you can implement once, and you can even build for hardware that you don't own. And the runtime is supposed to handle all of that. It goes back to what we were talking about in regards to the motion controller poses that you return. If you don't have say the index controller, for example, you can still develop for players that have that hardware without actually having that hardware, because the runtime, if you build it the OpenXR way, the runtime is going to handle sort of those offsets for different controllers. And that, I think that to me, at least as a developer, that is the primary benefit, because the amount of complexity that I had to go through to be able to ship, just for like the Rift and the Vive back in the day, it was tough. And there's a lot of testing that's involved there, trying it on all the headsets. And here you can just sort of you can be relatively confident that if you're only using like the Quest, for example, for development, or the Vive or the Index or the Varjo, then you can just use that, and then maybe farther down the line when you get the hardware or you have someone else try it on different hardware, you should always test on as much hardware as you can. That's always useful. But you can sort of know that the runtime is going to handle a lot of these things that you previously would have to do in game logic. That goes back to enhanced input as well.
Yeah,
since we're using the OpenXR action system. So the reason why there's no solid documentation just yet is because we are still working on the full-featured enhanced input support for OpenXR. You can totally ship with it now, like it works, but there are a few things that we really want to improve before we're going to release support for this as production ready. And one of the major benefits of using enhanced input here is that we're actually almost one-to-one talking to the OpenXR runtime, and the way that we do interaction profiles. And so Alex has opened up the input mapping context default, which is the default action set that we are essentially telling OpenXR that we want. So these are the bindings between buttons, physical buttons, or interaction on the controllers, to an action in Unreal Engine. And what this allows you to do is that you can ship your game, and if you only have one piece of VR hardware that you're developing for, you would not add all of the bindings for the controllers that you don't have. Actually, that goes against the recommendation for how you're supposed to develop for OpenXR. If you only have an Oculus Quest, you should only add bindings for the controller that you know and that you've tested on. So you would essentially, go ahead and delete all the other ones from here if you cannot test that. I've verified that all of these bindings work because I have all this hardware with the VR template, but you're probably going to build a lot more on top of the VR template, or not even use it at all. And then you should only add bindings for actions with the controller that you have access to. And the reason for that is that the runtime will pick the closest matching interaction profile for that controller. Something funny that you can try if you have an HP Reverb G2, HP Reverb G2, you'll notice that, for example, you don't have access to some of the buttons in Unreal Engine that comes with the G2, and that is because they are actually not specific to Windows Mixed Reality. They are specific to the Reverb G2. And this is a great time to also show that if you do have that headset and you're wondering why can I not assign the A and the B buttons for my motion controller, that's because you need to actually enable the HP motion controller extension that Alex just demonstrated here. So if you have that HMD and you're using those controllers, you should enable that. You should add those bindings to your input mapping context, which will then turn into the requested action set that we want the OpenXR runtime to bind. this whole translation between like enhanced input and what we call it inside Unreal Engine and what it actually means on the back end of OpenXR, that will all be explained in a future nice video that I'm going to produce when we have made sort of the final refactors and changes that we want to do to our enhanced input support for OpenXR. And a lot of those are very important, which is why I didn't really want to document them just yet and then have it changed in a couple of months. So know that there's already a lot of good chatter on the forums, actually, with a lot of answers to typical questions. I've been chiming in there quite a bit as well. And always feel free to spin up a new thread or head over to Unreal Slackers in Discord to talk about enhanced input support for OpenXR. Because there's a lot of folks who have already figured out sort of how to work with all this and solved some of the little potentially unintuitive stuff, like having the player mappable input config having to be required to be set. That said, I'm not going to try to go into, there's a lot to talk about there. I could do a whole stream on it. We definitely will once we have some of the final changes in. And the reason why some of these changes takes a lot of time is because sometimes we actually have to request changes to the OpenXR specification and the extensions before we can sort of build support for that so that it just works across all the runtimes. One of those, which I will touch on now since I already talked about it, is the being able to set priorities for action sets at runtime. This is currently not possible in all runtimes. They all haven't implemented it yet. When they do, when you do an add input mapping config function, which is called on the VR Pawn begin play, that runtime, or sorry, that variable for priority that you're setting right there currently doesn't work. It is only the priorities that you set within the playable, within the input mapping context that have been added to the player mappable input config. Those are the only priorities that will actually be active throughout the entire session of your game. Yeah, so Alex is showing the add mapping context functions. And that priority number right there currently only works in a couple of runtimes. I may or may not have posted that on the forums yet. I was going to add a little bit of detail about this because when this actually gets implemented by the runtimes, your game may or may not change because this will actually all of a sudden start taking effect. So if you have that set to priority 0 and say that's something that you pick up that now is input, that will now override anything else that you might actually want to do. Or vice versa. It might actually be lower priority, like in this case, set to 0, than if it is something that you actually want to consume the input, such as the weapon in the VR template. Yeah, I don't want to go into, there's a lot to dive into, and it should be done in a very good order from start to beginning so that you can get grasp your head around the concept of using enhanced input for OpenXR. But at least there's a little tidbits there potentially that may or may not have helped anyone try to understand this. But to get back to the topic which started this tangent of enhanced input, which is the hands in the VR template. Like I said, very simple implementation that allow you to just interpolate between all of these different poses. And if you don't want that, you just don't have to add the input mapping context for hands. It was separated out like that to make it easy to just remove all of it. Was there anything else in particular there, Alex, that you wanted us to dive into in regards to the hands?
Yeah, so just I'll yes and some of what you just said, because I love the new enhanced input system. I just started to wrap my head around it right before Unreal Fest, and then was trying to very quickly bake that into my talk. But first of all, if you decide, for example, as Victor just said, that you don't want the hands, you could remove the context. But then also you can actually go down, and this is how it was set up in 4.27 as well, and 5.0. If you scroll down a little bit above where we have motion controller, there's display device model. And that actually has the ability to select OpenXR, where OpenXR will actually decide, what headset, what device does it think you're using, and will display a device for you. Now you can also do custom, and then you can actually try to dig up like a touch controller, for example, and say like, I definitely want to use this one. And you can grab things from WebXR libraries. For example, if you want to get a lot of different newer ones, Victor and I were talking the other day about how you can't at the moment find, for example, the MetaQuest Pro controllers here, but they're pretty easy to get a hold of. Additionally, I just want to call out the fact that when we have the enhanced input system active, it makes it so easy to make a project compatible with VR, because it used to be a little bit janky before. If you had a project that wasn't set up for VR and you were trying to like migrate over things from like the VR template, you probably needed to go into your project settings. You probably needed to go in and mess around with the input there. And you still might need to do some on the project settings side, but at least on the input side now, if you go ahead to any project that doesn't have VR set up for it, and you go add, and you say add feature or content pack, and you click on virtual reality, the spectator cam, the VR pond, those things are pretty much going to work. Which is pretty cool. And then you can start to take advantage of the fact that the enhanced input system negates the need for creating things like dead zones, for example. It's very typical when you're mapping controllers to say like, well, I don't want someone to accidentally move the player forward. So you typically have a little bit of blueprint code that's trying to say like, if the value is less than 0.2, then you wouldn't actually use it at all. And those kinds of things are just baked into the enhanced input system as modifiers, I believe. So ultimately, when you end up actually just showing, here's how to make a character move, it ends up being really simple coming off of the pins you have available for the enhanced input system. And I was just going to show very briefly how easy it is now, for example, to like make a character fly.
Yeah, I was going to mention that change is very important for us as well, and how we ship some of this content, because it allows us to do stuff like we can ship a game feature plugin for Lyra that is designed for VR, without actually having to have a bunch of that stuff in the base project. So if you have all of these custom inputs for any project really, and you're using enhanced input, you can add those to your game feature plugin, and without having to add all of those axis and action mappings like we used in the legacy system as part of the base project. So, and when we talk about modular development, that can be really useful, particularly if you are working on small little projects here and there. You're doing architectural visualization for company X, and then you're doing it for company Y. And, typically you have a lot of same things that you do in all these projects, and then building yourself, a little plugin. Essentially, you could take the VR template and make that into a plugin that you can just add, probably a custom version of the VR template, but you can make that into a plugin, and now you just go ahead and add that and enable it for the project, and all the input will just work. Another way to look into this, go and look at the difference between the VR template in 5.0 and 5.1, and you can see how there was a bunch of like custom threshold values in 5.0 for the VR template, and now all of that has been abstracted and moved over into enhanced input. Another good addition there is that with OpenXR, if you want to customize for particular controllers, you are actually not customizing for particular controllers. You're customizing for particular interaction profiles. And this goes into a little bit of detail about like how OpenXR is built to be future-proof for controllers that doesn't even exist today, so that your game will work in 10 years, if it's a hit or not, or if you just want to play it. Like I go back and play old games I made that still work. But for future controllers, that game won't work because the game wasn't designed for those. But with OpenXR, it will. And these modifiers that we're looking at here, in this case, the dead zone, you can customize that for the different interaction profiles. And so one of them that's actually implemented in the VR template is for grabbing on the Oculus controllers. It typically feels a little bit better to have a higher, lower dead zone threshold. So it's actually not going to be in the action. It's going to be in the input mapping context default.
It'll be over here.
Yep. And the reason why is because we don't want to add a custom dead zone values to all controllers that are using this action. We only want them to be added for the Oculus Touch interaction profile. And so this simplifies it. You don't need to have like a select or a branch or a switch statement that is checking for different threshold values that you had to declare. Instead, this is all tied to the information that we're actually sending to OpenXR as part of the interaction profile. In this case, the dead zone here for grip is customized so that it just, UX-wise feels a lot better to grab something with a touch controller, that isn't just a default value that we added to all of the action inputs.
So if I'm understanding that correctly, Victor, this becomes kind of an override for whatever is set up at kind of the general level. Gotcha. So it'll use this unless it finds something that's more specific over wherever I just was. Yeah. in my IMC default. Yeah, cool. That's excellent. I didn't know that either. And then, yeah, just to echo what Victor was saying about how simple this all becomes. I just had it open, my extension, and then we'll get off of enhanced input, because I know this is a very exciting topic to us, but maybe not as much to everyone else. So over here, I have a bunch of slides about this, but I'll just scroll through these very briefly. This has just become so much simpler than it was for me. So in this is my character pawn. So this is set up to work either with gravity, in which it would become walking, or flying, where there'd be no gravity. But I'm just taking, that float value for move speed, getting the right vector of the VR camera, and adding a movement input. And then I just have a little Boolean that I'm checking for other reasons to see if the joystick is active. But really, this is all you need. Like, it's such a simple way to make yourself move, because all the dead zone stuff and all the things that are specific to controllers is being handled over in the enhanced input system. And I actually kept this one here because I use this with teaching, that I used to have this whole, is axis greater than dead zone, and, dealing with it sometimes on a per device basis. And you don't even need that anymore. In this case, I'm playing with changing scale. Just a quick little shout out that it's really fun to change scale in VR, make the whole world into a dollhouse, change scale smoothly up and down. Here, I just map it to the right axis on your joystick, and then I just have a way to reset it briefly. But it's literally just that node for setting world to meters. And then when I do update scale, I grab the motion controllers and the headset and set all of their relative scale as well, and just play a little haptic thing there. So yeah. Victor, do you think we should try to get to some of the questions that are popping up in the chat?
We can do that. Are we? Yeah. Why don't we touch on some of those now, and then we can head over to. Yeah, there's a ton.
There's a ton.
Let's go. I'm gonna go from the bottom, and then we'll walk our way back in time, since that might be the most relevant. Yeah, I've been talking so much, I haven't had a chance to go through these yet. Okay.
Yeah, it's been, chat is very excited. They've been blowing it up.
Yeah. While Victor's reading through a few of those, real quick, Dan, do you want to just show a little video we have for gravity gloves, by the way, the word grab, which is really just a little bit of an adjustment to the way that Victor set up the grabbing, where instead of the motion controller actually being the thing that is looking for something to grab, there's an additional component that's basically a little collision sphere, and that gets sent out via a line trace. And then anything that is close to that sphere, that's what actually gets grabbed, and it gets shot back using the move to component node.
We have a question about from Zach Burke here. Is the OpenXR plugin ecosystem improved from 4.27 to 5.x? In 4.27, for instance, you can't make one binary with both Oculus and Pico OpenXR plugins enabled. They fought each other. So that's actually, when you're using OpenXR, when you're using plugins that contain OpenXR vendor extensions, in this case, that's what Pico are using, they have different ways to implement this. And in this case, I'm not going to go into the details why, but sometime, particularly, I wanted to talk about Pico explicitly. In the future, they will be using the same code path, so that you can compile for any Android standalone HMD. This goes to any of the other Android-based standalone HMDs. But as of right now, there are a few differences in how these device manufacturers have built support for Unreal Engine. But it should hopefully not be too long before that's the case. And then we can also go ahead and make the appropriate changes on our end, and then you'll be able to use all of the extension plugins for standalone OpenXR-based runtimes between like Pico, Quest, XR Elite, etc.
Yeah.
For now, you'll simply have to either have a build script that builds it for Pico and it enables that plugin, and then you have another one when you build it for the Oculus. So Cyberwolf asks if there's any consideration by the XR team to enable rendering the debug command data to a texture, so we can add a 3D widget to make it viewable in VR. Not sure if that's exactly how we want to do it, but we're hoping to get to a lot more quality of life improvements when it comes to sort of iteration and VR dev this year. There has been a lot of work supporting OpenXR for a bunch of new platforms and devices. And so support and stability comes first, and then later down the line, we can go ahead and also improve the UX. And it's definitely something I even think, yeah, I've had a feature request in for that for quite some time. Life Art Studios is asking, what's Epic plan for mobile standalone VR pipeline? Are we ever going to get more rendering and performance features? Well, I'm happy to tell you that for Oculus Quest, we have gained 5% GPU time in 5.2. So that's one. We are currently working on, currently, when it comes to left and right eye and Unreal Engine, there are some differences in how that is being checked in the renderer, and we are working on unifying that entire pipeline so that Unreal Engine doesn't, there's no actual code in there that cares whether it's left or right. Of course, there's some code that cares because we need to draw too, but for a high level explanation, we are working on unifying that pipeline, which in turn will give us performance improvements, because we no longer have to have a bunch of if statements that says, you know, is this left or right? It will just be a unified pipeline that will send to either eye. And to elaborate a little bit more on that, you know, standalone VR is definitely a very big market, particularly if you're building games. And we do want to have really strong support for the mobile space in XR, and so there's some things coming there, other than just like unifying pipelines. Vulkan, improving Vulkan is an effort across all of Unreal Engine, not just specifically for XR, but any improvements made to Vulkan will ultimately mean improvements done to standalone VR as well, since we're running Vulkan on pretty much all of them at this point.
And Victor, on that note, really quick, I know you and I were talking about how important it is when people are developing for Android, for example, to use the little Android Vulkan shader preview method, right?
Yeah, so something that I've noticed a lot of developers don't know about and don't understand is that when you're developing in Unreal Engine, you are typically on Windows. You can also do it on Mac. And you're then actually seeing, in the case of the VR template, this is DX12 using the forward renderer for PC. When you then deploy to your standalone VR HMD, we are using a Vulkan and the mobile forward renderer, for example, and they are fundamentally different in how we decide to draw things on each pixel on your screen. And so if you are developing a game or experience for standalone VR, you should be working in the editor in the Android Vulkan preview level rendering. It's a couple of words there. It's pretty long.
Yeah, it's it is specifically called well, actually, yeah, it's just Android Vulkan, previewing Android Vulkan.
Yeah, I'm not sure where you have one of the default textures overlaid over everything there.
I think that's it's still compiling. Isn't that usually like a post-process thing? That's weird.
Yeah, if there is a PP, yeah. So some of those things. So okay, not a good example. Here's why you might be using like stencil buffers and stuff when you're developing. You can see all that fine on PC, right? And then you deploy to your headset, and you're like, where are my outlines? That's because the Vulkan, the mobile forward renderer, doesn't support a lot of post-process features. In fact, I think there's only a very couple. There's very few of them that are actually supported on standalone VR, and that's sort of not even on our end. It's like they're not supported within the renderer. You can't do. It's a bunch of transparency stuff. There's a bunch of bloom stuff. There's a bunch of stencil buffers and things that I'm not knowledgeable enough, other than don't tick these checkboxes in Unreal Engine and things are good. And so it's really recommended that you do enable that preview rendering level so that you can see in editor sort of a much closer representation of what you're going to see in the actual headset when you deploy to it. And so that's highly recommended. They are completely different renderers that you're using on PC versus what you're seeing on your standalone HMD. More questions. There's lots of questions. US questions, we'll leave that for a different stream. Okay, there's a question about OpenXR and specific to different vendors. I'm not going to read the entire question because it's not really within the scope of what we'd talk about. Okay, but it is specific about like custom forks of Unreal Engine. So many of the device manufacturers maintain their own fork of Unreal Engine for two reasons. One, to be able to make changes that are specific to their devices that we don't want to implement for anyone using Unreal Engine because they might be developing for any device, and we don't want to specify like, oh no, this feature in Unreal Engine only works for device X. And that's one reason, so they can prototype and build those. They also use them so that they can, build or make changes, and then they can submit pull requests to us, so that we can take a look at them, review them, and potentially implement their changes for the better. But that's only if it works for everyone, right? It's not only if it's specific to a device feature. What's important to know that we don't support these forks of Unreal Engine, and so if you have a problem or a bug or an issue with, for example, the Oculus fork, we are not in a place where we might be able to support you, because we don't know what kind of changes that might have happened on their branch, in the last couple of weeks or months or years even. They might have done changes that we're not aware of. That makes it very difficult for us to sort of approach those issues and figure it out. So if you have an issue and you're using the Oculus fork of the engine, know that the only way that we will actually be able to reproduce and try to fix that is if you're able to reproduce it in a vanilla build of Unreal. And OpenXR is solving a lot of these problems. As we move forward in development of both OpenXR and Unreal Engine support for that, you are going to see a much more an ecosystem that is much more cross-device and cross-platform compatible than what it used to be with the separate individual SDKs for all the runtimes and the different ways that they were doing things, which is why we deprecated the Oculus VR and the Steam VR plugins in UE 5.1. They will be entirely removed in 5.3. Good thing to know. They will still be there in 5.2, but they were deprecated in 5.1, and yeah, 2 engines versions later where we will be removing them. Vulkan preview, is there any way to make it more accurate? There's no make more accurate button. What you're seeing is what you're getting, but Vulkan is in active development on the Vulkan side of things, but also on the Unreal Engine side of things. So expect to see that mature and improve over time. Any plans to Kiantain is asking, any plans to include different types of player movement in the template? I know that there are a lot of different ways VR movement is implemented, so I understand sticking with teleportation, but it would be nice to have something like Pavlov or Alex smooth locomotion optionally out of the box. For the template, it is meant to be a very bare bones, simple implementation of this is how you go from button X till action Y. And for that reason, I don't want to bloat it with a bunch of options and settings. Instead, I would much rather like to see that as part of a VR content examples. However, there has been so much good community efforts around sort of showing how to solve all these problems, that at some point in the future, I think we will go ahead and develop a VR content example that would have all these things implemented in it, but the template is going to stay very bare bones for the foreseeable future. It's much better to have all these options and different ways to do things as a content example project where you can learn and take bite sizes out of that and put it into your own project, rather than having it as part of a template that is meant to be a very simple starting point for developers to just see how they can do the basic stuff like input and a form of locomotion, a form of grabbing, a form of interacting with an object that's in the scene, etc.
Oh, we just lost Victor. I bet he hit the leave button when he was trying to click a button that's nearby it.
Yeah, probably.
That's fantastic. I'm going through some of these great questions as well. I'm seeing a lot of interest as well in making VR as accurate as possible or as photorealistic as possible. And I don't think Victor will mind me saying that I feel responsible a little bit for a lot of people getting excited about the potential of what Lumen and Nanite can do in VR, but it's very important to know that it's not production ready. There's not a timeline yet for it to be production ready. And when I'm telling people how to make their VR scenes as photorealistic as possible, I'm still saying bake your lighting. If you really want the reflections to look amazing, maybe you can start to bring in ray traced reflections, but stick with kind of the tried and true methods for now when you're going for photorealism. Hey, Victor.
Hey, I'm back.
Welcome back.
Clicking around on my screen and just leaving the Zoom call. That happens.
I thought you were done with this.
Yeah.
No, definitely not. I can talk about VR for days, which anyone who's seen me on the stream before probably knows. All right, are we still doing questions? I heard you talking about Nana and Lumen, which is
Yeah, I just saw that there were a lot of questions about, with 5.2 coming, what is going to be the most recommended way to make your scenes as photorealistic as possible for VR? Should people be using Lumen and Nanite? And I think generally we say still no.
yeah, it's still a no. It's still very experimental. We just sort of got these technologies running on a high-end consoles and PCs at 60 FPS, which is still a little ways away from doing it twice at an even higher frame rate. But we've lately we're working on that, like, actively. The XR team is actively working on support for Nana and Lumen, and to make that run. But we're a little bit at the whim of sort of hardware development as well, because we need very powerful hardware to be able to do these things. But there's already some low-hanging fruit that we've been tackling, like I mentioned earlier, unifying the pipeline for rendering, which will give us some performance back, just not specific to Nana and Lumen, but any performance that we gain ultimately turns out that we might actually be able to hit some of these required frame rates that we would like to see to use these technologies in stereo. That said, if you are on the cutting edge of things, and I've even seen there, if you're not aware, there's something called reprojection when we're using VR headsets, which is essentially we just take the last frame data that we have, and we just move all those pixels in one direction if you're looking to the left. So you can run applications at half of the frame rate, and then just reproject every other frame. And if you have a project where that is acceptable, typically not a VR game that's highly interactive and fast moving, doing finger guns, but any VR game that's very interactive and you want good frame rate and it needs to feel very responsive, that is not something I would recommend. But for a product viewer, for like just viewing something in VR, architectural visualization, for example, running it at like a reprojected frame rate, like half, can actually be okay for your project. So it's worth for you to explore what your project might actually be okay with, even if you're not capable of hitting 90 FPS or higher with 99 Lumen. You might actually be able to use it for your purposes. But there's lots of things that might change in the future. So if you're developing a VR game, do not use 99 Lumen as of this moment. But I'm getting a 4090 soon. Going to use that with some high-end HMDs, and yeah, we're really trying to push the technology forward because we want it as much as everyone else.
Yeah, seconding the reprojection thing as well. PSVR 2 just came out. I got mine yesterday. It's using reprojection in many cases. I tried Horizon Call of the Mountain, which is built in Unreal Engine 4.27, I believe, probably a modified version of it. And I think it's only targeting 60 frames per second, but with reprojection, it feels super smooth, looks great. I think it's a very valuable solution to use in many cases.
I've seen a lot of questions about WebXR and running XR on the web. We have no plans to support WebXR natively as a build target in Unreal Engine. That is something that can be developed using our platform extension API, but it's not something that we are currently working on at Epic.
Should we show the adjacent kind of thing that's slightly coming online now?
Sure, and that will touch a little bit on VR support for pixel streaming as well.
Right. Yeah. So Dan, if you want to queue up our little video that is not actually WebXR, but what this is allowing for in this video you'll see is I'm using my computer that has an RTX 4090, and then I am broadcasting an experience using pixel streaming into the browser of a wireless headset. And I'm doing this locally with local pixel streaming, but it is also something that you could be doing on the cloud. With my company, we do a lot of live shows and experiences where we want people to have the best Unreal Engine experience possible. So we deal with pixel streaming quite a bit and trying to give everyone, RTX A6000s, or now as the Lovelace, Ada Lovelace 6000s come online, giving them those kinds of graphics cards as well. And being able to pixel stream not just to a browser, but also to a VR headset, and to kind of piggyback off of some of the WebXR input is very exciting, but it's still very early and experimental for what that is doing. And the way this is being created, by the way, is still, exporting a Windows build, with the pixel streaming plugin enabled, with a bunch of extra like launch parameters. It's not actually trying to export to WebXR as a native platform.
Morpheus asked, since the recent update, Valve Index controllers aren't being tracked anymore. I had to revert to UE 4.27. I tried all the HMDs, and I think you're referring to UE 5.1.1. I have not been able to reproduce that myself. So if you can either post it on the forums, you can at me. I'm just Victor Lerp on the forums. I'd be curious to see how you're capable of reproducing that. I have not seen that myself, and I haven't received any UDMs about it either. There was a question of Thought the 3X asked, what release is the XR Scribe? And for those of you who have joined us now, XR Scribe is our internal version of NVIDIA's VCR that Alex was showing earlier. We currently do not have a planned release for that, but I'd expect it fairly soon. 5.2, no. 5.3, possible, but we will see. I will also announce that on the forums and hopefully have some instructions on how you would go ahead to use that and for what purposes. Simon Dreyer is asking, is it possible to track multiple people's hands through Quest 2/Pro cameras? No, they do not return data from other people's hands. However, you can do that using Unreal Engine's built-in networking. So if you actually send that data from the player whose controllers you want to know where they are, you can receive that data on another client, another Quest on the network, and then you then have that data locally, and now you can draw those relative to your space. That involves a little bit of matching up your two tracking spaces so that they are aligned. And there's actually lots of games who have done this. I thought we would have a better solution by now, but you can just stand in the same location in the real world and then do the recenter option. In the past, I actually did a solution where we all just put our controllers down in the same spot in the room, and then with a little bit of math, depending on where the controller is, where you are, and where the center of your play space is, you can have it be like sort of an automatic thing. Everyone just puts the controllers in a ring. I had a piece of paper so that they were in the exact location, and that way you can get really accurate shared like co-location experiences, which I think is what what Simon is referring to here. Belly Arms is asking, can you change the default orientation of the OpenXR right aim, for example, so just the Vive is modified? I have noticed the Vive points up a lot more than the touch controllers.
Yeah.
The answer is, can you change this? It's almost always technically yes, because Unreal Engine, you have the source code, you can go ahead and change things. In this case, sort of the way that you would want to do this, the answer is no. And the reason why is because if you are building a cross-device application using OpenXR, we are relying on the runtime to give us accurate data here. Now, that said, I acknowledge your problem because I have the same thing in the VR template. I would like to have the pistols that are in there a little bit up higher on the Vive controllers, for example. And this is particular. To have a good UX for the player, no matter which hardware they're using. The OpenXR working group is working on improving the action system because we have acknowledged that these are problems that developers are coming across, and they would like to have a little bit of agency over these. And so the ability to expose offsets in the runtime, this is just an example. You may see some of those things in the future that will make this a little bit better. For now, if you want to solve this today and you want to ship something, the only way that you can do that is by actually manually doing that in gameplay code. So
just exactly what you're going off there. And Victor, I'm curious if you have a different method. I would typically use the get HMD data node and then do something like a switch on name, and then try to figure out what device someone's using and then have different behavior based on what we're finding.
Yeah, you can actually get the interaction profile directly. I believe we added a blueprint function for that. So if you right click, I am fairly certain we exposed this. So yep, get current interaction profile. So that's the function that I would use. And then I would recommend that you start by just printing that string, figuring out what the path that is returned there for the current device that you're using. And once again, it's worth doubling down on that. You should not make specific, this goes against a little bit about how you would want to design a cross-device application with OpenXR when you start doing hard-coded offsets for different interaction profiles. Particularly if you don't have access to that hardware, then you should avoid this at all costs. Maybe you can find someone who owns that hardware and you can have them test for them, but you should not submit bindings or anything particular to interaction profiles that you do not have the hardware to test on, because this could not work the way that you expect when it's running on a device that you don't have access to. But it is possible to see which interaction profile, not necessarily controller, is actually being used right now, and then you can make determinations based off of that. But like I said, depending on the timeline of your project, what stage in production you're at, if you can wait, this will get better. But if you can't, then there are ways to solve it right now for your use case.
Victor, I saw a quick question about smooth locomotion with the template. I did just want to call out that this actually is a smooth locomotion method using add movement input, but also for anyone who wants to do something like a dash teleport, that's pretty simple as well. So I just have a Boolean off of the normal teleport system that just says, does someone want to use dash teleport? And if they do, then instead of instantly going to where we're going, instead, we're just going to use a really simple timeline node here and have a start location and an end location, and we're just going to lerp between those vectors over a set amount of time. In this case, I'm doing it in a very linear way. This could be something that you ease in and ease out of. And I also use, by the way, that exact same node setup for a fade. So in Unreal Engine, there is a fade, what is it like? There's like a fade to black kind of thing in Unreal that works for anything desktop related. It does not work in standalone. So the way that I tend to get around that is actually just having a plane that exists right here in front of the player. And all I do is literally fade the opacity of that from black or white, to nothing, and just have that go up and down using that little timeline setup. And I use material parameter collections to change the opacity.
We have a question from Robin Hasenbach, who's wondering, will you make the VR template replicated in a future release? The answer is no. Replication adds a significant level of complexity that if you are just starting out with Unreal Engine, or you want to look at how you do things in Unreal Engine and you're coming from a different engine, replication adds a bunch of complexity that you don't need if you're not developing a multiplayer game. And so the templates by default will not be made multiplayer. However, you might see a version of how to build a VR multiplayer game in Unreal Engine as a separate sample project. In this case, I already touched on it briefly, but I am slowly working on a game feature plugin for Lyra that will allow you to use all of the gameplay frameworks and systems that we have in Lyra that we use for the shooter game example in Lyra. And so also worth doubling down, because when you say Lyra, people immediately think about the shooter game that's inside Lyra, but Lyra is the project. Shooter game is one of the experiences that you can play, which is built in a modular fashion inside a game feature plugin inside Lyra. And what I would like to see us releasing in the future is a game feature plugin that is specific to VR that will show you how to use the gameplay ability system, Epic Online Services, and everything else, enhanced input and everything else that's built specifically for Lyra, but for VR. I don't have a timeline on when that will be released, as I'm waiting on some new engine features that we haven't announced yet before I would like to build that. But you can expect that sometime in the future. I hope before this year is over. I really want to have that out before this year is over. 5.4 would probably be the earliest. But yeah, so that's the reason why you won't see that the templates being replicated by default. We have talked about having templates that are like, oh, the multiplayer first-person shooter template, etc. But we already have almost all of those solutions in like shooter game and Lyra. And so there's already really good examples of how to do that out there. Typically, if you use one of the templates, it's primarily for having a base project that can do very simple things because you have a very simple application you want to build, or for folks who are new to Unreal Engine.
I do see, real quick, there's a bit of a conversation around DLSS where they're wondering if it's supported or if you have any tips for just using DLSS with VR in general.
I would have referred to Alex there because he's used it a lot more than I have.
Yeah, so we are getting, in our experience, different behavior with DLSS across the different versions of Unreal. We're still getting the most stable results with DLSS over in 4.27. We'll usually use it for reflections. We want really nice mirror reflections, and then everything else is baked lighting. We are finding in 5.0 and 5.1 that it conflicts a little bit with TSR in particular. That being said, my understanding is DLSS does require a temporal, anti-aliasing solution. So I think you actually need to go to what's the other one, Victor? That's not TSR. That's temporal for anti-aliasing.
We have temporal anti-aliasing, and then we have temporal super resolution,
Sorry,
which is
yes,
our upsampling.
Right. Yeah, so if you do want to try using DLSS correctly in Unreal Engine 5.0 or 5.1, then yeah, don't use temporal super resolution. Instead, use temporal anti-aliasing. So not TSR, use TAA. And then note that all the nodes have changed as well. So you're not going to have a clean upgrade from 4.27 to 5.0 or 5.1. You'll have to reset up how all the DLSS stuff works.
Yeah, just to detail, if you heard, don't use TSR, use TAA. That is only in regards to using DLSS.
Correct. Yes. Not in general.
Yeah. And there are some improvements that we want to make to TSR, which is temporal super resolution, which is our anti-aliasing / upsampling technology, or downsampling, if that's what you want to do as well, in Unreal Engine. That is to make it work better for stereo specifically. And TSR is required to get like Nanite and Lumen to run at a decent frame rate. I do not know how DLSS works with Nanite and Lumen, but I can't talk. I can't talk for TSR because that's what we're testing with.
Yeah, it works. We've had really good results even with Nanite and Lumen for our very experimental cutting edge projects that don't need to ship to clients. So it's still something that we wouldn't try to ship, but it is something you should play with, and you'll see that it can work okay.
Someone was asking if hand tracking support hand gestures. There's no concept of hand gestures in OpenXR yet, and so right now you only have access to the data for the joints, location and rotation. I'm going through questions here as well.
You can manually create gestures, though.
Yes.
You can actually just have detect when these two fingers are within, half a centimeter of each other, and that's, that gesture.
There's also it was a long time ago I looked at, but there used to be, might still be, a plugin on the marketplace where you could actually record hand gestures, and then the plugin would sort of know and make the determination whether the gesture you're doing is close enough to what the player or user did. So there have been and might still be solutions for that out in the community. We touched on that. Oh, there's a question about the XR Creative Framework, which is a great tangent, because that is something that I just wrote a post about it on the forums. I will go ahead and link that in Twitch chat. Thank you very much, Sky, for putting that on YouTube. So in 5.2, we in experimental, we have a plugin that is called the XR Creative Framework. This is basically the backbone of being able to do VR at editor time. So if you've been working with Unreal Engine and doing VR in Unreal for a while, you might be familiar with the concept of the VR editor mode, which we've had for quite some time. With the move to OpenXR and the deprecation of the vendor-specific SDKs, we did an entire refactor. We have scrapped VR editor mode. It still exists in the engine, but as far as for us, it doesn't exist. We're not working on it anymore. Instead, we've developed the XR Creative Framework, which is not hard-coded to different devices. So it's worth noting that VR editor mode was hard-coded to basically the Oculus Rift and HTC Vive. Sure, it still worked on the Index because basically it was using SteamVR, OpenVR, which is the old version of SteamVR that's running, only works for, old. Anyway, and with the XR Creative Framework, go ahead and read the post. It's pretty much what I'm going to say right here. it's short, but it will give you the ability to essentially build XR creative tools in editor. So examples could be modeling tools using geometry scripting, pose tools for animation, and the first one up that we will be releasing will be the new virtual scouting plugin that is specific for producing linear media using Unreal Engine, and it's the most use case for VR editor that we've seen out in the world has been particularly for VR scouting. So that's the first XR creative mode that we will be releasing natively with the editor. We have no dedicated plans to, we don't have a set timeline for when or even if there will be any other tools that we will develop internally. But what's really cool about this framework is that you can build these tools using blueprints. Anything that's exposed in the editor, for whether that is for editor utility widgets or other various scripts that you can build in blueprints for editor time and tools, you can use all of them now in blueprints to build XR creative tools, which is super exciting. Barely just started working with this because it's so recent. But it is available as experimental in 5.2. And in 5. Sometime on main, after we ship 5.2, you should also be able to get access to the new virtual scouting plugin. And I can't tell how excited I am that it's all OpenXR, because it means that it will just work on all these different devices and devices of the future without anyone having to develop, explicit implementation for these devices and make them work. I would love to see the community building these tools and like monetizing them and putting them on the marketplace and supporting them and, building a community around them for all the people who want to use them. It goes, the possibilities are endless. But there are a lot of really cool functionality here, and we will continue to work on the framework itself to make it as extensible as possible, so that your studio, your team can build these tools that may be specific to your project or something that you might want to share with the community, so that everyone can use it.
Very cool.
Yeah.
I have also seen a lot of questions about like VR editor mode is not working. Yeah, it's because we've been working.
Yeah. I just have to shout out, I've been such a huge fan of the VR editor since it first shipped. If you guys search in the Unreal Engine archives for my name, we had like a special Unreal Engine article back in like 2017 and 2018, and you can see me being like, we're doing everything inside the VR editor. It's amazing. We can pull up our content browsers and move things around. And the VR scouting tools are really wonderful. Just being able to create like, a dolly track and mess with lights and, cameras and change all these settings and just feel like you're on location is very cool, especially if you're in a full virtual production workflow and dealing with LED walls and that whole setup. To previs a lot of that in VR is really quite wonderful.
There's a question from Todd Kleinhans. Hey, Todd. Any nanite for standalone timelines? So they're asking, when is there a timeline for when nanite will be supported on standalone XR devices? That is actually not a question that necessarily Epic would be able to answer, because when the architecture of the hardware that exists in mobile devices, when they're capable of supporting the pipeline that we use to be able to do nanite specifically, when they support it, then it will theoretically become possible to use them on standalone VR headsets. But that is a little bit outside the realm of sort of what we do here at Epic. We don't necessarily build hardware, and so we're a little bit dependent on the actual devices that we run this on to support it. Same reason why you haven't seen nanite on mobile, like on any form of mobile yet. I don't know what those hardware timelines are. Great question for the hardware vendors. So I'm also super curious. Of course, we want the prettiest stuff on all the devices, everywhere, all the time. Devana Boina Saibamshi asked, OpenXR works with Pico 4. Last time I checked, Pico has an OpenXR plugin for Unreal Engine. And so the answer to that one is yes.
Quick question from Jan about VR not working with groom hair. That's something we've run into a lot with our live performances.
It's broken. We know.
Yeah, right. But I was gonna say, like, it's not that terrible to just there's a little checkbox now where you can just say use hair cards. Hair cards work great. They can look great. You can make your own. And you can also actually even have like a switch, which we do. If we have someone joining one of our live theater shows from a browser in Pixel Streaming, we'll make sure that we're using beautiful, beautiful grooms. And if we detect that they're using an HMD, very much like the switch that Victor has at the beginning of the VR template to see whether or not to use the spectator cam in a certain way, then we switch everything to hair cards. And frankly, if your hair cards look good enough, most people can't even tell the difference.
That said, I was able to reproduce it not too long ago. I saw the conversation on the forums, and there's a ticket in to get that fixed. No timeline as to exactly when. Everything takes time, but we're aware, and it should work. There's nothing fundamentally there that makes it impossible to work in stereo. Still expensive to render, but like previously discussed, that's sometimes okay. Still going through some of the questions here. We answered that one.
Yeah, a lot of them have been kind of indirectly answered throughout the rest of the show.
ARVR Industries is asking, any updates about OpenXR eye tracking? It works if you enable the plugin. And on another note there, in 5.2, we actually implemented contrast adaptive shading. And we have also implemented the ability to turn on dynamic foveated variable rate shading for OpenXR HMDs that have eye tracking. I have verified this on the Varjo. We have verified this on a few other HMDs that use the standard path for eye tracking. And so you actually have dynamic, it's experimental, because we just built it, but there now is dynamic foveation, dynamic eye track variable rate shading foveation. It's a long word. I think you all know what I'm talking about. If you don't go read about variable rate shading, go read about variable rate shading, and these are some of the technologies that in the future will make it possible to do nanite and lumen at a high frame rate on really high res displays. Because we essentially don't have to draw all the pixels all the time. We can make very educated, we get very good data in regards to where the player is looking, and then we can then decide to render it very high quality where the player is looking, and sort of only draw like 4 times less or 8 times less or even more pixels in the areas where they're not looking. And we have an experimental implementation of this that is cross-device. So any device that supports eye tracking using OpenXR will this work. There will be this will be part of our release notes for 5.2 with details on how to enable it and how to preview it and how to test it. Matt Mon is asking, can we expect to be able to use deferred rendering for VR and mobile projects one day? The short answer is yes. The deferred mobile renderer is still experimental, I believe. We would like to see, if you are developing for PC VR, console VR, standalone VR, using the same renderer across all of them makes things a lot easier, which I'm sure you would know if you tried to do that. And so ultimately one day, it's also all the features that you get out of deferred that you don't get in forward. Dynamic lighting is much cheaper for one. We would like to see that, but the deferred mobile render is still experimental. But I did hear, was it you, Alex, or someone else that told me that you were actually able to run the deferred mobile renderer on Quest?
Yeah, so there's a little demo I did where I had a big nanite map, and I just posted the YouTube link to this in the chat. Wait, no, I didn't. Now I did. And basically, I had a big giant scene that had about 500 million polygons in it, and I thought, just for the heck of it, let me try building it to Quest. And I left on deferred rendering and all that good stuff. And then I was surprised to see it was running, and I thought, wait a minute, does Quest as a standalone device support nanite? And the answer is no. What nanite does that I think is very clever is it creates a fallback mesh for every mesh that it uses nanite with, and that fallback mesh is very, very low polygon. So what happened was, once we actually started looking at it in VR, it wasn't going through a bunch of nanite, pixel level LODs. It was just showing a very low polygon version of that mesh, and it was working well. But I bring that up primarily because it was like the fewest number of settings that I'd ever changed going between a desktop build and a Quest build. And one of the things that we didn't change was leaving the deferred renderer on, and it worked pretty darn well. And you can see in that video just, decent quality Quest rendering in there.
Just saw a note from Coyer Storado asking about subtitles. We do have live transcription.
We do.
Yes, if someone can paste link to how to enable that. But we also transcribe all of the live streams that we do. So after a couple of days after the video, like the VOD goes live on YouTube, you can turn on captions. And it's also possible to download. We still link the transcription, the whole text file in the YouTube VODs.
Yes, yeah.
Okay, cool. So which is a really useful way to actually, because these live streams go far, we hop back and forth between different subjects, mention really important things in the middle of something else, and it's really useful to actually download that text file. And I do a Control F. I've done this plenty of times to find I want to link to a certain section in a live stream, and I don't remember exactly if it was 50 minutes in or an hour and 50 minutes in. Go ahead and you can just search for key terms in the transcription file, and you'll see the timestamp when that sentence was said during the live stream, and you can then go to that timestamp in, or you can go to that time in the video, and watch it from there.
Yes.
Thomas Halpin is asking the selector on the menu with the thumbstick, so the cursor that you move around with the thumbstick in the menu in the VR template. On that note, I saw another question about how to get the template. We ship it natively with Unreal Engine, so if you want to use the template, the bare bones one, Alex also been showing some of the custom stuff that he's been building, which is built on top of the VR template. But you can get that you get that natively with the editor as long as you download the samples. You can actually uncheck that. You can actually uncheck and not download the template, so make sure that you have that checked when you install the engine. But make sure that you have templates checked, and then when you go to create a new project, you can pick the VR template.
I'll show that real quick. So here under games, virtual reality, you can have starter content if you want, and you call it, VR template, whatever. And then that will create it. And then as you saw earlier, you can also do it through the add feature there, add feature a content pack, virtual reality, and it will bring all those features into whatever project you already have open.
What's important to know about adding the VR template to an existing project is that there are actually some project settings that are specifically set for the VR template. For example, pretty much every other template and blank project is using the deferred renderer for PC. The VR template is using the forward renderer for PC, which means that just adding the VR template as a content pack to your project, it will not look exactly like it does, or it might not look exactly like it does when you create a new template, as the project itself is a little bit different.
Yeah, and similarly, Victor, I still hear people talking all the time about when and when not to use instant stereo. That's another feature that may or may not be checked in that scenario. What are your general tips and guidelines for that?
It depends, and it's best to test. Generally, we recommend that you do use instant stereo on PC. Also worth noting that the instant stereo checkbox does absolutely nothing on standalone VR because we're using mobile multi-view. Mm-hmm. It's the path for sort of optimizing what we're drawing on the left versus the right eye. These are both optimization paths to sort of be like, hey, well, I mean, we're seeing the same thing, a lot of the same things in both eyes. And there are different ways to optimize that so that we don't have to sort of compute that data twice. We can reuse some of the information that we did for the left frame and just copy that into the right. And so instant stereo is for PC. Mobile multi-view is the checkbox that you should have enabled for Quest. And it's worth noting, because I see a lot of conversations about this, and it's worth repeating, mobile HDR is not supported on standalone VR. Mobile multi-view is required for Oculus Quest. And this is outside of the realm of Unreal Engine. These are sort of support requirements that come from the vendors themselves, such as Meta. And so I saw a question about like mobile HDR for standalone VR. The answer is it is not supported, and there is currently no plan to support it. And mobile multi-view is required for Oculus Quest. Oh, and back to my question that led me to how to select the VR template. I just wanted to cover that first. Thomas Halpin was asking, the selector on the menu with the thumbstick, is there a way to dynamically adjust its area so that it can, is it possible to dynamically adjust the area where it can move if you have different menu pages? Alex, would you want to open up the menu logic? Because I can show where
Sure.
I'm actually already doing some of this logic.
Yeah, one moment.
No worries. The short answer is yes, you can dynamically adjust the area where you are allowed to move it. And there's actually a little piece of logic in the menu already. So it would be the menu blueprint. Yep. If you go up to the timeline.
The timeline there.
Yep. And then, okay, so go, okay, so on the, I think on the finished execution node, if you go
finished down
go
here.
down. Yeah. So this is where I'm setting the limits for how far the cursor can go. I am basically computing the size of not the canvas. I think if you go to the left, it's the yeah. So I'm actually getting okay. I shouldn't mention canvas, but we're getting the widget. We are looking at how big the space is where we're allowed to paint. And I am getting the size of that and then setting the limits based off of that. So this means that you can have, so for example, if you add a button to the menu by default and you have a really long text for that button, this logic will dynamically adjust so that the limit is now at the limit of the menu. And so if you want to go ahead and customize that limit based on whichever menu you're adding, you can go ahead and figure out what those limits should be and set the cursor location limit Y and Z variables. You would have to, obviously customize this code and sort of get that data in a different manner depending on which widget you're displaying, etc. I would probably take this piece of logic here and expose it into a function and only call it depending on X, Y, Z, whatever you're doing. But that will lock the limit of the cursor of how far you can move it so that it either goes beyond or stays within certain boundaries. There's a question from Analog Joker who's asking, VR project for HTC Vive, Quest, and Index. Should I use 4.27 or 5.1? If there are features that no longer exist, that doesn't exist in 5 that are really important for you, then the answer is simple. You have to use Unreal Engine 4. However, it's an engine version that we no longer officially support outside of some crucial bug fixes for SDKs that are particular to consoles, etc., and studios that are working on games for them. So my recommendation, use Unreal Engine 5. If you come across any particular caveats that you are considering, game breaking for you to be able to actually ship your project, please reach out to us on the forums. Let us know what they are so that we're aware and so that we can do improvements in those areas. But UE5 all the way is the short answer to that question. Particularly if you're looking to support your game for years to come, then if that's the case, then UE5 is the only answer. I know there are some, we've seen some, I wouldn't call them performance regressions, but by default, chaos on standalone VR can be very expensive, which means that, and that's not necessarily the chaos itself is more expensive. It's just that the way that it's configured by default might potentially cost you more on a standalone VR headset. And so you need to dive into sort of how to configure chaos and what kind of features you might be able to support using a lot of physics on like a standalone VR headset, which by default is not a lot. We don't have that much computer power to use, and so you always have to make some prototype. What was the phrase that we talked about that I always say? Test early, test often, and package daily.
Yeah.
Yeah, those are my 3 recommendations for, I typically put them as a mantra when I do game jams, but they really can be applied to your project as well. That it's not just a game jam project. Yeah, packaging daily, that one's important. Package. You'd rather know if something breaks in a build that looks good in editor a day or 2 after you made a change rather than weeks, months, years into development. I've seen people develop their game for like 6 months and never actually packaged. That is not a situation that I would like anyone to be in, because figuring out and solving all those problems can be really tough. And that's when there are specialists that come in, and you have to hire specialists to come in and figure out all those problems.
for quality of life improvements, Victor, you mentioned, I was telling you how one thing that I run into all the time is I start up Unreal Engine, I've got my project running, and I realized that my headset didn't properly connect. And my workaround for that in the past has been to go and launch either restart the entire project or go and launch a standalone game with Dash VR as a launch parameter to then get into VR. And if I heard you correctly, that is going to be changing soon.
Yeah, so in 5.2, which the release branch is available on GitHub, we've implemented support for polling. And so this is particularly useful for Oculus Link, because Link can die, the headset can go to sleep at any point, and then previously you'd have to shut down the editor, start Link, and then restart, start the editor again. In 5.2, we are continuously polling, so if Link dies, you just start Link again, and now VR Preview will become available. If you have any issues with this, please let us know about that on the forums. We recently implemented this. I've been testing it. It works well. We've had lots of reports from people being like, "Oh my God, this works now. This improves my workflow so much." And like, yeah, we know. Trust me, I do this every day. It's very nice that we now that it now works this way. What it doesn't support is if you're switching HMDs and runtimes. So if you are using the OpenXR Explorer tool that I pointed to earlier, and you're testing on like MetaQuest or a Index or Varjo or whatever, and you're switching runtimes, you will still have to restart the editor switching that. We are not able to pull which runtime is being used. We do that when the editor starts. But for Link, or even unplugging your like your Index or your Vive, and like restarting the runtime, yeah, as long as it's the same runtime, that will still make it possible for you to do VR Preview again.
Hooray.
More questions? Let's see. I can also go through some of the notes I wrote down prior that I wanted to talk about. Oh, I want to mention the VR notifications component.
Yeah.
Which for 5.2, so VR notifications component, it's existed for quite some time in the editor. It essentially adds a bunch of delegates. And so delegates basically API calls for like, hey, we lost tracking on a controller, for example. And in 5.2, we now, all of the available data that we have through OpenXR in the runtime, by saying that all the available data, the things that we actually know about, that the runtime tells Unreal Engine about, you can now use the VR notifications component for that with OpenXR. So yeah, controller tracking lost, etc. I think HMD connected works as well. I tried that one and a couple of others. Yeah, it's just useful to know because I knew about it at some point. I forgot about it and then got reminded about it. So it's worth mentioning. We could also talk a little bit about OpenXR extension plugins for Unreal Engine. I did see a question about this on the forum. The user was looking for a solution, and they didn't know the fact that there's actually a MetaXR plugin on the marketplace. There's also a Microsoft OpenXR plugin on the marketplace. There's a Varjo OpenXR plugin on the marketplace. And what these plugins are and what they do is that for all these different devices, these vendors have different things they want to support. Their device, some devices have X amount of cameras, some of them have hand tracking, some of them have eye tracking. They want to support all of their device features, even if they might not be part of the OpenXR specification, which is what any OpenXR runtime need to follow the specification to make sure that a developer can know that if this user is using runtime X and runtime Y, that both of them support the same thing. However, it takes time for some things to become generic enough where all runtimes implement support for that. But a hardware manufacturer who's developing amazing, super cool hand tracking, they obviously want their developers to have support for that as soon as possible. They do that by developing vendor extension plugins, and support for that in Unreal Engine comes through the vendor's plugins. So in this case, Varjo, Meta, Microsoft. There's a Pika one. Do we know of any others?
Did you say Vive?
Oh yeah. Vive for XR Elite. And so if you plan on supporting device-specific features for these headsets, you're going to have to use these extension plugins that most of them are available on the marketplace. Some of them will probably shipped somewhere else first in beta or whatever. But hopefully they'll end up on the marketplace. But that's where you go ahead and find support for some of these device-specific features and how you can implement that. Because we generally do not implement a sort of device-specific features natively with Unreal. And this actually saves everyone some time and some headaches. Previously, say there was a bug in the Oculus plugin. It was discovered after we shipped an engine version. Now Meta had to wait until we shipped the next engine version before their fix could actually be in there. In this case, they can just go ahead and update the plugin on the marketplace, and they don't have to wait for us, and we don't have to maintain code and features specific to their products. We did. Oh,
I was just saying, awesome. It looks like most of the questions have slowed down a bit. So if you two have any final points or bits that you want to make sure you get out, please feel free. This is the time.
Yeah, and I have some time after the stream, so I was gonna hop into the Unreal Slackers voice channel if anyone want to come and chat. Yeah, I'll probably have like at least half an hour. And so if you don't know about Unreal Slackers, it's the best unofficial Unreal Engine community on Discord. Yeah, I'll hop in the into the voice channel there when the stream's over, if you just want to chat or we have some more questions.
Yeah, I saw a couple of questions about RTX DI, which is an NVIDIA thing over in the NVIDIA branch. One of the questions was, will it be in 5.2? I don't think so, and that's an NVIDIA choice because they're the ones actually developing which plugins are in their branch of Unreal and which ones become more standalone, like DLSS. That being said, I do want everyone to know that RTX DI looks great in VR. They did a webinar not too long ago with a big amusement park with like hundreds and hundreds of real-time ray traced lights casting shadows. And there are a few weird little artifacts with stereo with left eye, right eye, but it's very promising for just, the potential future of having an insane number of movable colored ray traced lights inside Unreal. So I like it quite a bit.
Very, very cool.
Yeah.
Well, awesome. I want to make sure that everybody who is in chat and wanted to ask questions and all that know how to get a hold of you two. If you're open to, obviously, Victor, you'll be hanging out in Slackers for a bit, like you said, but is there any way for people to reach out to you if they have questions about today's talk or just other things around XR and VR in general?
Sure, yeah. My DMs are open on both Discord and Twitter. However, I receive a lot of them. I read all of them. But oftentimes they are either questions that I don't have the answer to, or they don't have enough information in them for me to even try to. I'm not going to start a conversation to get more information out of you. You need to bring that to me directly. That said, if this is not something that you want to keep secret, which most times you should not send me in a DM anyway, that's just general practice. Like, that's not just me or Epic. Just if it's something you want to keep secret, make sure you do that through a channel that is actually considered, under NDA or whatever. Post it on the forums, post it on the Slackers. You're much more likely to get an answer from me and from anyone else in the community who might have the answer if you're posting that publicly. And the forums is probably the best spot to do that for two reasons. One, they are monitored by our moderators on the forums, as well as me. I keep an eye on the XR development category daily. And it retains in Google, right? Like, you can actually, you essentially help others by helping yourself by posting a really good question. Even better, provide as much detail. I see so many questions every day that just does not have enough information, and someone is not going to go fishing for that. But if you do provide all of the information related to your problem, or question about how to do something, or asking for resources or links, the more information you provide there is going to make it much more likely that you receive an answer from me or someone else in the community. It's very rare that the folks who have the knowledge that you're looking for are going to answer. Like, they might know that, like, I would be able to answer this if I only had a little bit more information. It's rare that that person is going to spend the time to ask you for that information. And so it takes a little bit of practice, particularly when you're getting started and you don't have the terminology, and might not even know the words, or kind of not even know what you're asking. That's common. But then I would suggest Unreal Slackers. If you're not really sure, try to use Unreal Slackers, but also know that real-time chat like Unreal Slackers, it's common that most people don't check that every day. They go in, they browse it a little bit, they might come upon your question, which does have all this useful information, and they might be able to answer it. But trying to find some other folks to just pitch these ideas back and forth with and try to learn some terminology is a good way. But if you do have what you think is a bug or anything else, provide as much information as possible. And you might see a response from me or Alex or any of the other thousands of people in the community who are super knowledgeable about all this stuff. And post it in the right category on the forums. Yeah, that's it. I'm Victor Lerp on Twitter. I don't know if do we have the thing down here?
Yeah, there
Yes.
Okay, the thing's down there. And on Unreal Suckers, I'm also Victor Lerp. You can find me there. And like I said, much more likely to receive an answer if it's a public question. Yeah. Go ahead, Alex.
Great. Thanks, Victor. Thanks, Tina. Yeah, so I'm iBrews pretty much everywhere. I'm primarily active on Twitter and YouTube and LinkedIn to a certain degree. And it's funny, I was about to say, well, you can find me in the metaverse. Khov, Khov, asked, is it possible to make a concert using only VR? How many people can attend at the same time? All I'll say is that's a big thing my company does, usually through Unreal Engine pixel streaming. The most common way to see me is through some kind of virtual event where we have a lot of attendees using virtual machines in the cloud, attending through VR or browsers, or just watching a YouTube live stream. So we have a few more of those coming up that'll be announced shortly. Come find me at South by Southwest if you'll be there. I'm going to be on 2 panels about XR, one about live events, one about architecture. There's also going to be a very exciting, I can't announce it right now, but a very exciting arena scale VR hyper photorealistic Unreal Engine experience at South by Southwest. You'll know more when we get closer to that date. And also, I just want to give a quick shout out to a couple people who were helpful in today's stream. There's someone named Travis Does Stuff that was really great when I was figuring out how to do gravity gloves. You can find him on YouTube. And then for the not WebXR pixel streaming VR stuff that's going on right now, that's primarily the work of TensorWorks, who maintains the pixel streaming plugin for Unreal Engine. And William Belcher over there is the one who's really pushing for some kind of very accessible solution for getting VR streaming from a browser. So thanks to those guys. And yeah, thanks again, Tina and Victor. This was a lot of fun.
Yeah, thank you, Alex. And Tina. And Dan.
Yeah.
And everyone. Dan, yeah, the whole
Yeah,
team.
this guy.
Everyone.
Thanks, Epic.
There's more people behind the scenes.
Yes, for sure. And thank you both so much for taking the time to speak with us in the community about this. There's so much information that got jam-packed into this stream. It's going to be awesome for people to be going back through over and over. There's so many tiny little things. So that's, if any of you missed any part of this, I know this was a really in-depth conversation, which is great. So don't worry if you missed anything. We post all of our streams in video format afterwards on both our Twitch and YouTube channels at Unreal Engine. You can watch that on demand whenever you want. Victor spoke a little bit about it earlier, where we also have captions where you can go through and make sure you're getting all of that information. So make sure you check that out in case you missed part of the conversation today. Also, you can keep up with us at Unreal Engine on all of our social media, as well as come say hi in the forums, as we also talked about. Please do come join us in the community there. It's a great place to get information, as well as also just meet other like-minded developers and get help with your projects, or just inspiration with going forward, or just good conversation. It's a great place to be, so come join us there. You can also find all of the latest news there, as well as all of the links associated with today's stream in the main announcement post, which is also linked in the description of this video. So go check all of that out. One last big thank you to both Victor and Alex. Again, thank you so much for coming on, celebrating VR Week with us by talking about all these wonderful, great tips that hopefully everyone watching can implement into their own projects in the future. And again, make sure you reach out, come join us, and I will see the rest of you in next week's episode of Inside Unreal. So make sure you come back on Thursday, and we'll see you then. Bye, everyone.
Bye, everyone.
Bye.